So my name is Kumar Utkarsh, and I am an electronics and telecommunication engineer. And currently, I work at IIT Bombay as a research assistant in National Center for Aerospace Innovation and Research Lab. So, having said all these things, now let's begin with yesterday's recap. And before beginning with yesterday's recap, I would like to share a few things with you guys. So yesterday, a few of you guys asked about installation of Ubuntu on like dual boot or WSL or VM. So regarding this, once this workshop is over, when we will be providing the recordings, then I'll be sharing you detailed documents as to how to set up dual boot or how to set up Ubuntu on WSL and VM. So that will be covered after this workshop in the recording section. And for the ROS to set up all those things, yesterday I had explained you how to set up ROS 2 and everything. But today we will be going through that once again. I have prepared a detailed GitHub README. You can just refer that and set up ROS 2 on your system, just following the steps. So also there was one more doubt yesterday that someone had asked how to do autocomplete, like how to set up colcon autocomplete. So in that GitHub README, I have also provided the steps and the code, the command as to how to install the colcon argument complete so that things get auto completed. So these were the three main things I wanted to share with you guys. So without wasting any more time, let's begin. So before beginning with the recap of yesterday's session, I would like to ask you guys a few questions in the poll. Just answer that so that I can like get to know like what you have learned yesterday. So there is a poll, you can answer it. So the correct answer for this is node. So node is the fundamental building block of ROS 2 that is responsible for performing a specific task. So let's move on to the next poll. You can answer this one as well. Question is, which command would you use to see the real-time position and orientation data flowing from TurtleSim node? Again, the correct answer for this is ROS to topic echo turtle1 pose. We had covered this yesterday. Okay, so I think most of you guys have understood yesterday's concepts, so that's very good. Let's move on to the last question before we begin. Then we will have more such questions. So just answer this one as well. So the question is, which ROS2 concept is used to request a one-time action like creating a new turtle in the simulation? Okay. So the correct answer for this is service. Yesterday we looked at the spawn service. Using that we created or spawned new turtles in the TurtleSim node. Okay. So most of you have got it correct. That's really great. So let's begin with the session. So just to recap, I'll just quickly recap. So about what is ROS2 and why do we care? Yesterday we covered that ROS2 is a framework, and using this we can build complex robots, and it provides us a modular approach to build robots. And the philosophy of ROS2 is don't reinvent the wheel. That is, if someone or a team has already worked on building something, as engineers we should use that and build on top of it rather than building everything from scratch. So this was about ROS. I'm going quickly because we have covered in detail yesterday. Okay. So getting started with the installations and all those things. So I'll show you a quick GitHub README, which we will be providing you guys. So this is a detailed GitHub README I have prepared. it will be covering everything what we have covered in the session. And for ROS2 installation, you can just go here on ROS2 Humble. You can just click this link. It will open the ROS2 documentations using which you can install ROS2 using copying these commands in the terminal. Again, yesterday we had discussed these things. So from here you can install ROS, or if you don't want to go there, here are the codes. You can just copy and paste it in your terminal from here. And to install VS Code, again, I have given the command to install VS Code on Ubuntu. Again, TurtleSim, how to install TurtleSims, and all the nodes, all the commands which we used, CLI commands, all of them are mentioned here. So it's in detail, right from creating packages to code, to setting up the environment, to file structure. And we will be looking at this as well today, and these as well today. So this is the detailed GitHub README, and here we will be having the code for today's session. Everything will be shared. Okay, so installations will be covered here. So we have covered installation. We have sourced our environment. Yesterday we looked at what is sourcing. Like if you install ROS, but your system doesn't know that something known as ROS exists. So to tell your system, you have to source ROS. Okay, so we looked at what is bash rc, the script that runs every time whenever a new terminal opens, and we can paste any command inside the bash rc so that that command also runs on its own whenever a new terminal opens. So we place this command in the bash rc file to source ROS every time. Okay, so we looked at ROS2 core concepts yesterday. ROS2 nodes, topics, services, RQT graphs, messages, all those things. We looked at what is TurtleSim. So again, TurtleSim is a ROS2 node which helps us understand ROS2 in a very intuitive and graphical manner. And this is the command to install TurtleSim, and this is the command to run TurtleSim. We will be looking at this today once again. We covered what are ROS2 nodes yesterday. So what are ROS2 nodes? Again, they are pieces of program which are supposed to perform only a specific task. So for example, there is a robot, and robot has multiple sections in it. It has camera, it has controller, it has motors, and all those things. So we write specific nodes for each of them so that they perform a specific task. So this was about nodes. This makes the design scalable and modular and easy to debug. And one more advantage of node is that everything is present in small pieces. So if one of the pieces fail or one of the program fail, entire robot does not stop. That's the main advantage. But if we write everything in one program, then if one line fails, the entire robot would stop. So that's the main importance of nodes. We looked at the CLI commands yesterday for nodes as ROS2 node list, ROS2 node info. We saw what was the information it was displaying. It was displaying publishers, subscribers, it was displaying services, and various other things. We looked at what are topics yesterday. So again, there are nodes. How do nodes communicate with each other? Nodes communicate with each other with something known as topics. Topics act as a middleman. So one node does not know whom it is communicating with. It simply sends the data to the topic, and the data, then the other node which wants to communicate subscribes the data from that topic. So we were looking at topics. And we were looking at what are publishers and subscribers. So publishers and subscribers are nothing but nodes. If a node is performing an action of publishing or sending the data to the topic, we call that node as publisher. If the node is performing an action of receiving the data from a topic, we call that node as subscriber. So it's nothing but nodes, but they perform specific actions. So based on that, we call it publisher node or subscriber node. And also topics are unidirectional. That is, we can only send and receive data from the topic. There is no two-way communication of request and response. We covered it yesterday in detail. Topics understand only a specific language. Those languages we refer to as messages. And if a node wants to send data to a topic and another node wants to subscribe, the language should be same or the interface type should be same For example, we looked that when we want to send command velocity to a topic, we have to send it in which type? Let me, okay, we'll look at that later. We have to send it in geometry messages twist type. Only then we can send velocity command. We looked at that if we want the current position and orientation of the turtle, in which interface does the topic interact? It interacts in turtle1 pose top, turtle sim turtle sim messages, pose message. So we have covered this. Now we covered this also. What are topics and top commands related to topics? Topic list, topic info, and what is the command of ROS to interface show? Again, geometry message. So what this command will do? This command will show what is the structure present inside the geometry message. So what was the structure present inside? Linear xyz, angular xyz, out of which we were using linear x and angular z to send commands to our turtle in the turtle sim. Why? We had covered yesterday, there are two types of drives, holonomic and non-holonomic. So it was covered in detail. So then this was the topic from which we received the position and orientation data of the turtle. And again, the message type for this was the pose message. Moving forward, so we had also moved the turtle yesterday using the commands mentioned here. We had looked at what are ROS2 services. So they are basically a request response system. Just like when you go to a restaurant, you place an order or you place a request to the waiter, and the waiter gets you the food from the kitchen in response. So this is a two-way communication. You place a request, you get a response. It's bidirectional, unlike topics which are unidirectional. So this was about the services, and we looked at few services like spawn, kill, set pen. Set pen changed the color of the track of the turtle. We looked at reset service. So this was basically about services. And again, services have their own message or communication language. So you have to take care of that. So for example, the spawn service communicates in this language, turtle sim srv spawn. How did we know this? We knew this by doing this ROS to service type. Yesterday we did everything, like we reverse engineered everything to find out the final structure of the service, the request structure, and then we sent a request using command line to get a response. So this was about services, and we looked at what is RQT graph and how it gives us a visual interface to see what's happening at the backend. And to install RQT graph, you can use this command, and the command to run RQT graph is simply this, RQT underscore graph. Okay. And yesterday we ended at this slide. So this was all the things we had covered yesterday related to the theory part. And of course, we had covered everything hands-on. So till now, if you guys have any doubt, let me know so that we can cover that and proceed ahead. So what we'll be looking at today? So today we'll be building our own node using Python and ROS2. Yesterday we saw that how to control the turtle using command line command CLI commands basically. But today we won't be controlling using CLI commands. Today we will be writing our own program to control the turtle, and we will be debugging and seeing what's happening at the backend using CLI commands. So today we'll be creating our first ROS2 Python node. We will be creating our own Python ROS2 package, the Python package and CMake packages, and we will be looking at what is the file structure. You need to have VS Code for this. So we will be, I have shown you where you can find the command to install VS Code, and we will be interacting with our robot, which is the turtle in our turtle sim. So let's, so these are the steps to make the package, and this is the command to install VS Code. But let's begin with doing everything in the command line itself. Okay. So first I'll build the package, then I'll quickly explain what is a package. So okay, so yesterday we had seen that every time when you run ROS2, you have to source it. We are not sourcing it because we have already placed the source command in the bash rc file. So right now, when I opened a new terminal, ROS2 got sourced automatically. So no need to source. So what is the first step to create a package? So what we will do is, first we will come to the home folder. Then I will do mkdir. We will name the package as, we will have to create a workspace. So what is a workspace? So workspace is the main, you can call it the main directory or the main folder, which consists of all the ROS2 packages. Package related to control, package related to message types, package related to launch files, package related to camera, all those things are stored at one place, which we refer to as workspace. So we will create the workspace first. So we will use this command mkdir. Mkdir stands for make directory. Okay, directory is nothing but a folder in simple terms. Okay, so we will name our workspace as turtle sim underscore ws. Ws stands for workspace. This is the general trend followed across the globe. If you make the workspace in this format, you can understand anyone else's code, someone else can understand your code. This is the general professional way or the general global way of making it. So what you do is you name your robot. So for our case today, our robot's name is turtle sim. You name your robot, then underscore workspace. Okay. If I press enter, the directory has been created. Now let's go inside the created directory. How will we do that? We will do that by using cd. Cd stands for change directory. I want to change my directory. Right now I am in the home directory. I want to change it to turtle sim workspace. If I press enter, now you can see I am inside the turtle sim workspace directory. Basically, I'm inside the workspace. Now, if I do ls, ls stands for list. It lists all the things present inside the directory or folder. If I press enter, nothing came because nothing is present. It's an empty directory. Now here what we will do, we will create a source folder, mkdir src. This you have to do like this every time you create an src folder. If I press enter, it will create an src directory inside the turtle sim workspace directory. If I press enter, now if I do ls for list, now you can see an src directory is present. Now again we will navigate inside our src directory. Src stands for source. Again we do ls, nothing is there. Now here we will create our first ROS2 package. So to do that, I am opening the GitHub Readme side by side so you guys can also refer it. So these are the steps. You guys, if you wish, you guys can refer. Okay. Can you share the GitHub link? Yes, I'll be sharing everything. So you want the GitHub link right now in the chat? Let me share it in the chat itself. But besides that, also we'll be sharing it. Okay, so I have shared the GitHub link in the chat. You guys can refer there. Okay, so we have created the src folder. Now we will create our first package. So we will name that package. So let's see the command to create our first ROS2 package. So the command to create it is ROS2 pkg create. Pkg stands for package. ROS2 package create. What will be the package name? We will name our package as turtle underscore script. So this package will contain all the scripts or programs related for controlling the turtle sim node. Okay, ROS2 package create, package name, which is turtle script, build type. Build type, then we have to give that we want, what type of package do we want? We want a Python package or a C++ package. So right now we will be creating a Python package. So you do that by amint underscore Python. And then you give the dependencies. What are the dependencies your package depends on? So in our case, our package right now, I'm giving the dependency as RCL Pi. Now what is RCL Pi? RCL Pi stands for ROS client library for Python. Py is for Python. So it is the basic library which we use to write a script using ROS2 with Python. Okay, so this is the entire this thing to create the package. Now if I press enter, now our package has been created. Now if I do ls, now you can see this is a turtle script package which has been created here. Now let's go inside this package and see the file structure of this package. So again, I'll do cd and I'll go inside the package. I'll press enter. Now I'll do ls. And now you can see these things are present inside the package. Now when you create a C++ package, the file structure will be different. We will be looking at it. When you create a Python package, the file structure will be different. So this is the file structure for Python package. You have package.xml, you have setup.py, and you have turtle script. These are the three main important things. Okay, so where will we write our code? We will write our code in this. So how will we go inside this? We will do cd turtle script. If I press enter and press ls, you will see there is init.py available in it, just a constructor for initialization of the package. Okay, so here we have created our first ROS2 package, the commands and all the things. Now we will go to VS Code and we will write our first Python node to control our turtle sim turtle. So how do we do that? I'll just go back, just do this. I came here, turtle sim workspace. Now what I will do code space dot. If I write this, then VS Code will open automatically at this location inside turtle sim workspace. So now if I press enter, now you can see VS Code has opened and the location is turtle sim workspace. Let me increase the font. Okay, so VS Code has opened and the location is turtle sim workspace, and inside the turtle sim workspace we are mainly having the src folder, and inside this we are having our package turtle script. And where will we write our first code? We will write our first code inside src turtle script package inside the turtle script folder where we had init.py. Now what we will do, we will go here, click on new file, and here I will write the file name. Let's name the file as draw_circle.py. So we will be writing a Python node which publishes data to the command velocity topic, and the turtle sim turtle draws a circle. So we will be writing the first node regarding this. Now if I press enter, this file has been created. What is in the package.xml? In the command I had put the dependencies. So in the dependency I had put the RCL pi. So here the RCL pi dependency is there. We will also be putting more dependencies as we move further, and we will be looking at what is setup.py again once we write this node. So to write this node, I'll quickly just copy it from the GitHub itself, and then I'll explain it to you guys. So how you can also do that, you go inside the src folder. Let me just increase the font size. Okay, you go inside the src folder. Here you have turtle script for people who are doing along with me. So I'm just sharing how to do. There you go inside turtle script. Here you click on circle drawer.py, and here is the code. You just click on this copy raw file, copy the code, and paste this here. So okay, yeah, so this is our code to draw a circle using the turtle sim circle, using the turtle sim node. So let me explain you guys the code line by line, then we will run this code and see what's happening. So this is the first line. This is nothing but the file location where your Python's interpreter is present. Again, if you guys know, Python is an interpreter based language and C++ is a compiler based language. So when we run C++ code, it gets compiled before running. So whatever errors are there, it will show you that these errors are there. But in case of Python, it doesn't compile before running. It gets compiled line by line while it is executing the code. So you'll get to see the error when the program comes to that line. So that is what an interpreter does. It compiles the code line by line at runtime, whereas a compiler compiles the code before running the program so that you can see all the errors in one place. So this is the interpreter path which we have given. It can be same or it can be different in your system. Then we are importing the RCLPy library. What is RCLPy library? The library used to write ROS to code or ROS to node using Python. From the RCLPy library, we are importing the node class. Okay, so we won't be covering object-oriented programming in this workshop. So basically, this is a class which we are using. So yeah, so from the RCLPy, we are importing node class, and from geometry messages message, we are importing twist. So this you guys will understand. Yesterday we were seeing that to command our turtle, we have to use the interface type geometry messages message twist. So here what's happening, geometry messages is a package. In that package, just like I showed you guys, we have created a turtle script package. In that package, there is a folder named as turtle script in which our code is present. Similarly, geometry messages is a package. In that package, there is a folder named as message, MSG. Inside the messages folder, there is a file named as twist. It is exactly twist.msg. Okay. It is exactly twist.msg. We will be looking as to how to create our own messages, but it is a twist message. We also looked what's inside the twist message and what is useful for us. We will be using linear x and angular z. Okay, so here we have imported the twist message type. Here we are creating a circle drawer class and we are inheriting from the node class here. Then here we are defining the constructor to initialize everything. And here we are giving the node name. To initialize this constructor, this class, here you have to give the node name. So just keep this in mind. We have given the name as circle drawer, but we have given the Python file name as draw circle. When I run this file and I do ROS to node list, this name will get appeared. This is the node name, which is the name of this node, circle drawer node. Okay. So we just give the node name here. It can be anything. You can even give it your name, but yeah. Then what we are doing, we are creating a publisher object. So how do you create a publisher object? To create the publisher object, you use this command, self.create publisher. Yesterday, we were publishing to this topic, turtle1 command velocity topic, using the command line. Today, we are publishing to this topic using this program. So we are creating a publisher. We want to publish to this topic. Now, what is the language of this topic? Like, what is the interface type? Interface type is twist. This topic understands only twist message, which is present inside this one. And this is the, again, some buffer we are giving. This is QoS profile, which as a beginner, it's not important. Okay. So here we have created a publisher, and this publisher will publish to this topic with this message type. Okay. Now, for now, okay. For now, we will leave this and I'll make few changes in the code, but we have created a variable here, timer period, and we have given it a time period of 0.1 second. And what we are doing here, we will come to this variable later, but what we are doing here, we are creating a timer object. Yesterday you were seeing that when I was writing the command and publishing using command line, there was something coming as 1 hertz. That is, at every 1 second the command was being published. So here we don't want to publish that slow, that after every 1 second we want to publish the command. We will be publishing the command at every 0.1 seconds. That is, our frequency will be 10 hertz, 10 times faster. So to do that, to achieve that, we are creating a timer object using this function create timer, and here we are giving the time period, which is 0.1. And after every 0.1 second, what this function will do, after every 0.1 second, it will call this function move in circle. So what is move in circle function? This function, we are defining this function here. Here we are writing all the logic for our turtle to move in circle. So let's look at this. So what I'm doing here, again, I'm creating a message object of this twist class. I have created a message object. In it, I am publishing linear.x. Yesterday we looked at it, that we publish only linear.x. So for now, let's remove this. So we are publishing linear velocity to the turtle as 0.5. Let's not keep it as 0.5. Let's keep it as, say, 1.0, or okay, let's keep it as 2.0. So we are publishing the turtle a linear velocity of 2 meters per second. And we are publishing the turtle an angular velocity of, let's not keep this high, let's keep this 2 as well. Angular velocity is 2 radians per second. Okay. Once we have stored the data inside this linear x variable and z variable, we will call the publisher object we created. Here we created the publisher object. We will call it, and we will then use this publish function to publish the message. Again, what were messages? Messages were the actual packages or actual things sent to the topic. So this message contains this linear x and angular z data, which we have given it here. The values we have provided it here. What is this message? This message is of twist type. What did twist type consist of? It consisted of linear xyz, angular xyz, out of which we are using only linear x and angular z. So we have published the message to this topic. Now, how is it publishing? After every 0.1 second, this function is being called. In this function, this program is written. So after every 0.1 second, this program is executing. And here, using the publish topic, we are publishing to this topic. Okay. And this is what we are printing every time this function is getting called. So this is nothing but the print statement in ROS 2. And again, for now, we will leave this. We will look at it later. So this is the basic program or the basic requirements to move your turtle using in a programmatical way. Okay. Now here it's just the template or structure. Here we define the main function. We are giving args as none. Then we are initializing RCLPy. Then we are creating an object of this circle drawer class. Then we are spinning the object continuously. So what this thing does is it keeps on spinning the node until and unless we want to stop our node. It keeps on spinning it in a loop. Then once we press Control C, it will stop the node will get destroyed, and RCLPy will shut down, and this is the entry point. So basically this is just the template. The main logic is present here. And again, here we are creating timer and publishing it. So this was the basic code. Now we cannot run this code directly. We have to make a few changes in the code. So for that, we will go to package.xml. Here you are seeing that this code is depending on RCLPy library. Besides that, it is also depending on the geometry messages library or package. So we will just copy the geometry messages and we will go and we will go and paste it here. So here now our code is depending on both. So we have pasted it here, and here in the setup.py, this is the basic structure which comes here in the setup.py. You just have to give the entry point. So for that, I will just copy it from here. I'll go in the setup.py. Here I'll copy this entry point and I will paste it here. Now in our case, our file name is draw circle. So I'll just rewrite it as draw underscore circle. The package name is turtle script, and again, okay, here we put as draw underscore circle. Okay, so this is basically the executable name and this is the file name. It is not necessary that this name should match this name. It can be different. This name can be circle drawer and this name can be draw circle. This name should be draw circle because the file name is draw circle. This name can be different, but for convenience, we name both of them same. So basically we will be calling this name, whatever name we have put here. This is the main executable name. Okay. So here we have added the entry point here through which our package will recognize there is some script known as draw circle inside the package. So we have done the setup.py configuration. We have added the dependencies here and we have written our node. Now, what is the next step? What we will do is now inside the turtle sim workspace, we will do something known as colcon build. So right now you saw that when I did ls inside, okay, let me do ls once. Let me just clear it and do ls for listing. There is only src and log present, but when the moment I do colcon build, two more things will become present. So what is colcon build? So colcon build is building the workspace. Basically, it's compiling the workspace, checking for errors. If everything is fine, it will give colcon build successful. Else, it will show you the errors. Then you have to fix it. And once you have fixed it, everything works. Then you can run the node. If I do colcon build, here you can see that build was successful because it started and finished. So our workspace is ready, our package is ready. Now if I do ls after colcon build, you can see two new folders have come, build and install. So now let's test our code if it's working or not. So to test our code, what I will do is first I will run the turtle sim node. ROS2 run. Where is the turtle sim node present? Inside the turtle sim package, ROS2 run turtle sim. From that, inside that package, I want to run the turtle sim node. Okay, if I press enter, here our turtle is there. Now let's move this turtle using the node which we wrote just now. So how do we do that? Again, every time, since you created a new package, so you have to tell the system that I have created a new package. Now how will you tell the system? You have to source the package. Okay, so whenever we are opening a new terminal, ROS is getting sourced overall, but the new packages we have created, they are not getting sourced because they are built by us. They are not like pre-built packages. So you have to tell the system, okay, I have built this package, let me use it. So how do you do that? You do that by source. You go in the install folder, there you click go to setup.bash. This is the basic command used to source your workspace every time inside the workspace. There is a shortcut, you can avoid this. We will be looking at this at the end, but as beginners, you should source it. If I press enter, my workspace has been sourced. Now my system knows that there are newly created packages. Now if I do ROS2 run, I want to run the turtle underscore script package, and inside that I want to run the draw circle node. If I press enter, you can see that the node we wrote is drawing the circle. And after every 0.1 second, as I had showed you, that this drawing circle is getting printed. Okay, now let's see what's happening at the backend. But before going to the backend, Let's see it in the command line only. What are the things active? So how will we see what are the things active? We will do ROS to node list to see the active nodes. So two nodes should be active for now. One is the turtle sim node and other is the node we created just now. The name of the node is circle drawer. If I press enter, you can see this node, which is this one running here, and this node, which is the turtle sim node. These two nodes are active. Now let me see what information I get about the node which I created. So ROS to node info, I want to get information about circle draw node. If I press enter, now you will see that circle drawer node doesn't have any subscribers yet, since in the program we haven't wrote any subscribers for it. It has only one publisher and it is publishing to turtle1 command velocity with this message type as we did it in the program. There are no service servers or anything, so it's not showing anything. And these are some default RCL things which we don't directly interact with. So basically there is only one publisher inside the node. It is showing us that. Now let's do ROS to topic list. Again, three topics should only come. This, and this. Pose, command well, and color sensor. Okay. Now let's see what's happening inside the command velocity topic. So how do we see that? We see that using ROS to topic echo, and I want to see inside command ROS to topic. Okay, turtle one command velocity. I want to see inside this. If I press enter, you will see that we are publishing 2 meters per second, and angular also we are publishing as 2 radians per second inside the code. Here you can see we are publishing 2 and 2. Our node name is circle drawer, and after every 0.1 second we are calling this function to publish data to the turtle. How are we calling it? We are calling it using this timer, and we are publishing. Why do we use different .py file in VS Code? Do we have to link all of them together? Sorry, I didn't get your question. Like we are writing Python file, so we name it as .py. Can we write a code? No, no, no. You don't write code inside init.py. That's the general structure. You always write your code, whatever node you have to write here. You create other files. Can you please explain package.xml and what are dependencies and setup.py? Also, what does init.py do? Okay, so I'll explain that. Let me just cover this first and I'll come to that. So after every 0.1 second, this thing is getting called and it is getting printed. So this was the basic thing. And let me just quickly cover what's happening at the backend, then I'll answer those questions as well. Okay. So how to see what's happening at the backend visually? So that we see using rqt underscore graph. If I press enter, now you can clearly see that this is the turtle one and it has this command velocity, and this is our circle drawer node which we are running, and this is publishing command velocity to this topic, and this turtle sim is subscribing from this topic the command velocities and moving the turtle. So this is the basic thing what is happening at the backend right now. These two are nodes, turtle sim node, circle drawer node. This is the topic to which it is publishing the command velocity data in the message type of twist. We are publishing angular z and linear x. Okay. So this was what was happening at backend. Coming to the doubts. So package.xml, you don't need to worry about these structures and all those things. These are just whenever you build the package, these things will come by default. I'm getting following error. Yeah, so there is some issue in sourcing, and also you have to like just do it as how, like how I am doing. So here everything is same. All these things you don't have to write the program. Whenever you build a package, these things are pre-written. We don't have to worry about these things. The only thing we have to do is here here we have to name our executable. In our case it is draw circle. Then we have to name the script, the package in which we are, and then we have to name the file. The file is draw circle dot py, this file, and then main. This is what you have to do. And another thing to keep in mind is you should not forget to use this. And if things are not working, then figure out that where is this interpreter present in your system. The file location may vary. Because of that, if this thing is not present and if you are not using this, then I will show you an alternate as to how to you can run still without putting that, but make sure this is present. And inside package.xml, all these things are pre-written. You just have to put the dependencies you are using in your code. What are dependencies? All the libraries and packages on which your code depends. In our case, our code is depending only on RCLPy and on geometry messages package. So I have just pasted these dependencies, RCLPy and geometry messages. And if now coming back, if you don't get the interpreter path, so without this, what you can do is you can just, I'm stopping this once. Okay, also init.py again, it's an empty file. You don't have to do anything. It's just, it comes on its own whenever you create a new package, and you don't remove that or else things might not work. Keep it intact, and then clicking on this folder, then you go to file and write your new file here. Okay, now I'll quickly show you how to make the node executable without putting the interpreter path. So for that, what you do is cd, you go to your workspace. Our workspace name is TurtleSim workspace. Inside TurtleSim workspace, where do I want to go? I want to go inside the src folder. Then inside src, where do I want to go? I want to go inside the turtle script package. Then inside turtle script package, where do I want to go? I want to go inside the turtle script folder where my nodes are present. Okay, if I press enter and if I do ls, you can see this node is present, draw circle node, but it is not made an executable by default. So how do you make this an executable? You do chmod plus x, and then you just write the file name draw circle.py. If I press enter, now it is converted into an executable. Now if I press ls, now you can see it is green. So now even if you don't put this thing in your code, it will still work. But if you don't, if you want to avoid these long steps of making it executable manually, then you simply put this line in your code. Then you don't have to do all those things. So this was like the way how to go about it. So basically you are getting module error because it is not able to find your node. Okay, so till now, if you guys have any doubt, just let me know. We have successfully moved our turtle using the program. If you guys have any doubt, just raise your hand, unmute, or write in the chat. And if you don't, then also write that we don't have doubt. No doubt. Okay. No doubt. Good. Then what all is default after creating a package? What all we should change in the code? In the package, once you create the package, this entire file structure which you are seeing now, everything is by default. These all things are by default. You just have to go inside the turtle script. This is the turtle script package. Okay, where I'm hovering my cursor. This is the TurtleSim script package. Inside that, there is a turtle script folder. You just have to go inside that, Click on new file, create a new file, whatever name you want to give it. Don't forget to name it as .py, that is important. Here you write your new node, whatever logic you have to write. Close this, go to package.xml. Whatever your node is depending on, just paste it here. Where will you paste? Below license, above test or depend, in between. You paste it here. Nothing you have to change. Go to setup.py. Everything will be same. Just paste this line here. Your executable name, your file name, your package name, main. Just do this much. Save it. Go to the workspace. Just go to the workspace. Just go to the workspace to colcon build. Once it is built, just source it. How will you source it? Using this. Okay, here we don't have the command. How will you source it? You will source it using this command, source install setup.bash. Once you have sourced, then you can simply run your node. How will you run your node? ROS2 run. What is the package name? Package name is turtle underscore script. What is the node name? Node name is, what is the executable name mainly? But in our case, the file and executable names are same. So executable name is draw circle. Just press D and tab, it will get completed. Press enter, it will start running. This is what it is happening right now. Okay, so till here everything is clear then. So let's move forward. Now our turtle is drawing a circle. Now let's try to draw a spiral instead of a circle. So how do we draw a spiral? So let's see that. So right now our turtle is moving in circle. Okay, our turtle is moving like this. Now I want to draw a spiral. How do I draw a spiral? I have only two parameters. One is the turtle speed, the linear speed at which it is moving forward, which is linear x, and I have another speed, the angular speed at which it is turning about its own axis, which is angular z. So this is my turtle. Consider this as a point object. This point is moving forward with a linear velocity in x direction in meters per second, and this point is rotating about its own axis with an angular velocity in radians per second. This is my turtle. Okay, so when I move my turtle at a constant speed forward and at the same time I rotate it at a constant speed, what will it do? It will make a circle. Okay, it will make a circle. Now if I change one parameter, that my turtle is rotating every time at a constant speed about the angular z, but after every iteration its speed is getting increased. So what will the result be? Whenever, so my turtle will move forward at the same time it is rotating, so it will go like that, but after every iteration, whenever the function is getting called, its speed is increasing. So instead of coming here, it will go forward. So like this, every time, since the speed is increasing, so the radius is increasing. Whenever you increase the radius, it will not end up making a circle, rather than it will end up making a spiral, because the speed is increasing, so it will not come at the same point back again. It will go slightly below it. So let's try to make this using the program. How will we do that? It's very simple. Here I have created a counter variable. Initially I have given the value as 0.0. Okay. Initially I have given the value as 0.0. I'll add the counter here. Self.counter, and I'll uncomment this line. Now let's see what's happening. Initially, the counter value is 0, and the timer calls this function move circle for the first time. So what will be the x value be? So x value will be 2 plus 0, which is 2 meters per second. For now, let's reduce this value because or else the speed will increase too fast. Let's keep it as this. Okay. So for the first time, when this function is called, the linear speed will be 0 0.5 plus 0. So initially my turtle is moving at 0 0.5 speed. Okay. And the angular speed will be constant, which is 4 radians per second. So one command sent to the turtle. Next time when this function will be called after 0 0.1 second, my command, so when this function will get executed, once the command is published, then it will come here, and to the counter variable we are adding 0 0.5. So initially the counter variable was 0. One time it got executed, linear speed 0, 0 0.5 plus 0, and angular speed 4, published the linear speed, printed this, then the command came here. Then I'm incrementing my counter variable by a value of 0 0.5. So every time what I am doing, self.counter is equal to initial value of counter, current value, plus add 0 0.5 to it. Now my counter variable value is 0 0.05. Now when the second time this function will call, what will be the output? What the output will be? 0 0.5 plus 0 0.05. Now my turtle is moving at 0.55 speed. So my speed has increased. Next time again to 0.05, again 0.05 will be added, same process will repeat, and gradually my linear speed will keep on increasing, keeping the angular speed same. So with this, my turtle should draw a spiral instead of drawing a circle. So let's test this. I have made changes. I have saved the code using Control S. Now, since we have made changes to the code, again, we have to compile the workspace. How will we compile? We will compile using colcon build. Here I have compiled the workspace. Now let me source the workspace. How I will source install setup.bash. If I press enter, so let's run turtle sim node ROS to run from the turtle sim package. I want to run the turtle sim node. If I press enter, turtle sim node is up and running. Now since we have sourced our workspace, let's run our node. So ROS to run. What is the package name? The package name is turtle underscore script. And what is the node name? Node name is draw circle. If I press enter, now you can see that instead of drawing a circle, my turtle is drawing a spiral. So what's happening is that after every iteration, when this function is getting called, the speed of the turtle is increasing. So it is moving forward. So it is not able to complete a circle. So it is drawing a spiral, but the angular speed is constant. You can see the speed of the turtle is gradually increasing, but angular speed is constant. So using this, you can draw a spiral. So everything is clear till now. In that case, we can move forward. Okay. If everything is clear, then let me ask you guys a question. I have shared a question in the poll. Just answer this. The question is, which command is used to display the structure of a message type? For example, the message type is geometry message twist. Okay, so the correct answer for this is ROS to interface show. Using this interface show, we get to see what's inside the message type. We get to see the structure. What will be the structure? Linear XYZ, all those things. Okay. So most of you guys have got it right. So that's good. So we have seen how to write our first ROS2 node. We are able to control our turtle. What is the behind logic for what? What is the logic behind self.t? It is self.t. Okay, so w- whenever you create anything inside init and you want to make it global, then you write this self. Again, it's not necessary. Whenever you are defining init here, you are creating an object of itself. So it's not necessary that you write self. You can you can also, like, I can write utk as well, and here I can put UTK. It will still work. No issues will come. It's just that we use self because it's the general trend as how things are done. It is not necessary that you use self. You can put anything. Whatever you make it as self, it will act as a global variable. Like I have put, let me just undo this. Like I have put here self dot counter. So now this counter will behave as a global variable. You can access this counter in this function as well, self. But since timer period I have not put self, so you cannot like access timer period in this function. It's a local variable for this init function only, the timer variable. But this is a global function in the entire code. So basically, mm, to make things global, you can use self. Okay, so till now we have covered this, so let's move forward. So what we have done till now, we have created our workspace. We know what is colcon build, we know what is bash rc, we know what are packages and all those things. Now we have also tried moving our turtle using the node. We are publishing velocity commands at 10 times per second, and we know all these colcon build commands. So now basically you are familiar with ROS2. You know how to write your Python node and control things. So now we can move forward to few advanced concepts as a beginner. So now what we will do, we will try to accept user inputs. Right now, what I am doing is, right now, if I want to give the velocity command, I have to hard code it here. Like I want to move my turtle at 4 radians per second. But there are ways which we can write the command while write the speed or the velocity while writing the command itself, ROS to run. So it will be dynamic. At runtime, you can change the values inside the node. So for that, we will be using something known as parameters, which we will be looking at. And then we will be creating our custom messages and service types. Till now, we were using the pre-built types, geometry message, or the spawn service type, which had a request and response and all those things. But now you will get it more clear as to what they exactly are. We will be writing our own service servers and service clients. As to what are service servers, a service server is a place where all the processing happens and the client sends a request to it and gets back a response. So we will be looking at this, and you'll get to know about the flexibility of ROS2. Then we will be covering this Capstone project, which is the Polygon drawer. So right now what's happening is that either we are able to draw a circle or we are able to draw a spiral. But now we will be looking at how to draw any shape, for that matter any polygon. So polygon is basically any enclosed figure. So the smallest polygon is a triangle with 3 sides. Okay, so what we will do is we will just enter the sides and the side length, and the turtle will draw that on its own. So we will be looking at this. But before we jump to this project, let's clear these things as to what are custom services, custom messages, what is service server, and what are service clients. So let's look at this first. So for this, we will be creating a new package. So we are already inside our Turtle Sim workspace. We are already inside our Turtle Sim workspace. Now we will navigate to the src folder, cd src. If I do ls, I only have one package. Let's create another package which will store custom message and service types, the interface types. How do you do that? You write ROS to pkg create What is the package name? Let's name our package as turtle underscore msgs, just like we had for geometry underscore msgs messages. We are naming it as turtle underscore messages. And build type of this package will be, we will make this package as a CMake package, a C++ package, and we won't be writing any dependencies for it. If I press enter, a CMake package has been created. Now, if I press ls again, you will see this package here, turtle messages package. Now let's go inside this package. So cd turtle messages, let's press enter, see what's inside. So you saw the structure of the Python package. It had setup.py, package.xml, and a folder named same as the package name, turtle script. These were the three main components. This has a different structure. It has CMake list.txt instead of setup.py. Package.xml is still intact, and it has two main things: include and src folder. Inside the src folder, you write all the C++ files, the main CPP files, and inside the include folder, you write the header files, the HPP files for C++, which we won't be looking at. But this is the basic file structure. Now let's navigate back to our VS Code. Now you can see inside the src, there are two packages present, turtle messages and turtle script. This is the file structure of turtle script package. This is the file structure of turtle messages package. The file structures differ. Okay. Can you show? So I showed you like how to build the package. You just have to follow the command. This command you just have to write. It will build the package. ROS to package create, write the package name, then build type as aim and CMake. This is basically what's happening. Or let's do it like this. Okay. Okay. So inside the turtle script package, we don't have to do anything. We will be creating two more folders inside the turtle messages package. So how will we do that? We will do that by, if I do ls, these things are there. Now inside the turtle messages package, I will do mkdir. This is for C++. What we did in past was Python. Yes, definitely. Okay. So mkdir, we want to create a messages folder, so msg, and we want to create a services folder, so srv. Yesterday we saw that we wrote this. Okay, let me show. Here you can see geometry messages. Similar in our case, it is turtle underscore messages, and then there is a message folder which we are making now. And we will, yesterday we saw that we had a srv folder as well, turtle sim srv spawn, like that, if you guys remember. We will look at that once again. So now if I press enter, now you can see srv folder and messages folder have been created. Let's navigate back to VS Code. Here you can see messages folder and srv folder has been created. Before looking at messages, let's look at srv. So what we will do here, let me just open this. Okay. Okay. So we will go here inside the turtle messages package. Inside the srv, we will create, I will just, there's no way to copy, I'll have to write. So what we will do, I will go inside the src folder, we'll click on new file, click on it, then we will just write this. So we are creating a custom service type structure, request and response structure for our own service client and service server, which we will be building. So the service server which we will be building is, we will be writing a node that calculates the area of a rectangle. Whenever I give it a request of length and breadth, it will give me a response as area. So for that, we are writing our own structure. because we don't have any pre-existing structures to perform this, wherein I give a request of x and y and I get a response of x into y multiplication. We don't have any structure for this. So when we don't have any existing structures for this, we have to create our own structure. So that's what we are doing. So we are naming this as compute rectangle area dot srv. Don't forget to name the file name as .srv. If I press enter, a .srv file has been created. Here you can see, and this is empty. Now we will be writing the request and response structure in it. Simply copy from here, paste it here. This is basically what is present inside the structure. Yesterday we were seeing this using ROS to service type. So it was showing us the, like in the post service, or was that the post service, or whichever service there was, like in the spawn service, we had to give the x, y, theta, name of the turtle as request, and in response we used to get the name of the turtle, that this turtle has been spawned. Yesterday we looked at that. So here we are writing our own request. You don't have to write like this request and response. It's just for understanding. So we are creating a length variable of type float 64. It will basically be a decimal number of 64 bits. So this is our request. Then you separate the request and response by these three hyphens. Then we write our response. So I will send the request as I have a rectangle of length this much, width this much, give me a response. You calculate the area and give me a response. So the response will be float 64 area. Again, this is a variable name. You can just write it like this also. Anything you can write. It's just a variable name. You can write anything. So this is the custom request response service type which we have created. Now what we will do, once we have done this much, we will navigate to CMake list.txt. Again, just like setup.py, this is how it will come on its own. You just have to make a few changes here. So everything will be same. I'll just copy paste it from here only. So this is the clean CMake list.txt. Everything is same, but I have removed the commented parts. These things will be present before only, and these things in the package.xml, just like you add dependencies, here also you have to add dependency in the find package. So we have added dependency geometry messages, and you have to add this as well, ROS ideal default generator. This is like the basic structure what we follow. So there is nothing about understanding here, and we will just remove these things for now. Again, for the entry point, we have created a new service type. So we have given it here. From the SRV folder, find the compute rectangle area.srv service. We have given it here. If I press save, CMake list is ready. Now let me go to package.xml. Again, package.xml, you add the things which your package is depending on. I don't think it is depending on anything. So here we have created our SRV, custom SRV. Now let's go to the scripts folder and create our ROS2 service servers and service clients, custom service servers and service clients, and there we will use this. So to do that, let's again come here. Let's go to the turtle script. Again, in the turtle script, we will name this file as this area service. First, we will create the service server, area service server. So what I will do is I'll go to the turtle script, create a new file. Here I will write as area underscore service underscore server dot py. Why I'm just seeing the name and typing it is because it makes it easier when we are adding the setup.py. We don't have to write it again and again. I can just copy it from here, save some time. Okay, so area service client is there. I'll just copy and paste it here, and I'll explain you guys this. So what's happening here? So we have created a new node, which is a service server. It's basically a node, but it is behaving like a server, which will accept request and process the request and give back a response. Okay. Again, we have added the interpreter path. If we don't add the interpreter path, we have to manually make it into an executable. Then we have added the RCL then the node. Now this time you can see, like in this script, we were using geometry message, and this was the twist message which we were calling. But here we are, now it might work. House ideal is not added. Okay. I might have missed that. Yeah, you can
Yes.
ask.
Actually, service area service server is a node, but if I want to put some put input in some node and get an output, we need to create a service server, or you can, or I might create a node simply.
Definitely you can.
Both things are correct. If I only
Oh,
create a node
yeah.
in which we can get an input from the user and showing some output,
Yeah. But
is it correct?
why?
But if I
it
want,
it is correct, but we create a service just for modularity. For example, if I simply create a node, then every time I'll have to run that node, and while running I'll have to pass the current values as parameters and get the output. But for example, say some other node also wants the area of the rectangle. Now how will I give that? So for that I create a central server, which whose task is to just calculate the area of the rectangle based on the request. So if there are 100 nodes and 100 nodes want the area of the rectangle, everyone will send request to the server, get the response as area. So this is just for modularity. You can create your own node which simply gives the area length and breadth and get the response as area. But to make it more modular, there is a central hub which can calculate the area, and multiple nodes can send request and get a response. So this we are taking a very simple example, but when building complex robots, so there will be a central hub, everything will get the, you'll send the request, you'll get a response. So for that, so hope you got it.
okay, got it.
Yeah. So we will be looking at how to like mm, manually send the request instead of creating a service. But now we are looking at how to create a service. And the most important thing why I'm showing how to create a service is to make this concept clear that you can create your own custom message types and service types. So here we have created the turtle messages package. Inside the turtle messages package, we have the SRV folder. Inside that, we have the compute rectangle area.srv. Inside that, we have this structure which we will be using. So how we did that using command line, we used to do ROS to service list, then we used to do ROS to service type for that service, then we used to do ROS to interface show to look inside what was there. So we got to see that, okay, this was there inside it. Now we are doing everything like in a forward manner instead of going in the reverse manner. So here we are using our turtle messages package. From that SRV folder, we are calling the compute rectangle SRV. Now again, here we are creating a area service client class. We are initializing, inheriting from the node class, giving the node name here. We are declaring parameters. So these are nothing but parameters. So we will look at it what are parameters, but though, okay, let's look at it now only. So parameters are basically variables which you can change at runtime. I could have directly given length equal to 5, but I have given it in form of a parameter. So by default, if I don't specify the value, it will take as length 5 only. But at runtime, if I give length as 6, so this value will get dynamically changed, and the length value, it will store the length value as 6, and based on that value, it will calculate the area and give as a response. So here we have declared the parameter. Here we are getting the value of the parameter. So it will get the current value 5 if there are no changes at runtime. If there are changes, it will get the changed value which we have put while using CLI commands. Okay, let me just minimize this. Okay, so here we are creating, just like we created a publisher object, here we are creating a, okay, this node is for client, I guess. Self.client. Service client, I have named it as service server. Let me just rename to area service client. Okay. So right now we are creating a service client which will send request to the server. So here we are creating a service client. What is the request type which it will send? It will send the request type of compute rectangle area. What is inside compute rectangle area? We just now saw. This is inside it. So request type is this, and this is the service name. So we are naming our service in calculate as calculate area. So when we will be creating our service server, then we will be naming the service server as calculate area. So this is nothing but that. Just like spawn, kill, we are writing our own service here. Now the service client is waiting for the service server to get active. It, like, it can happen that due to some reason the service server node failed and it is not active. So for that, service client is continuously waiting so that service server node becomes active. Okay, and till then it is just printing that waiting for service. Once the service server client becomes active, it will come out of this while loop and go in the next section of the program. So here, once it is active, it will send a request. What is the request type? Compute rectangle dot area dot request. Inside the request, we had length and we had width. This is the length we had stored here. We are passing it here as a request, and we are passing this width here as a request. Then this is something which might be a little advanced, but here we create a future object and we call the service. We send the request to the service asynchronously. Now, what is asynchronous? So there is something known as synchronous and there is something known as asynchronous. So if we send call, if we don't use call async, what will happen is that when I send a request to the service, the server might take time to process the request. And if we don't use async, then the code will get blocked here. It will not move forward. So we use asynchronous just to make this code non-blocking, that the code keeps on performing its task and it does not get blocked here after sending the request. So that's why we use async, just to send this request and then keep on doing your task, and whenever you get the response, then come here and perform whatever you need to perform. So we sent the request. Now we are doing our normal task, whatever this node is supposed to do. When this node gets a response, it gets stored in the future, and once it is done, then once the node response has come, it calls this function response callback. Once the response has been received, we check this using add done callback. Once the response has been received, it calls this callback function. Now what this callback function does, it gets the response out of the future variable or the future object in which the result or response is stored. So here what I am doing, from future, I am getting the response and storing it in the response variable, local variable I have created. Now what was the structure of the response? The response was getting sent in form of area. So variable name was area. So here I am printing area received and response.area. So it will print the response which it has received. The calculated area will get printed. And again, this is the same thing which we discussed earlier. And it will try to do that. If it fails, then it will print the exception why it failed. So it is working in a try catch block. So I will come to this once again. Let us first create the area service server. Then we will get to understand it in a much better way. So this was the node which will send request to the server. Now let's create the server itself. Area service underscore server dot py. Now let's look at service server. Let's copy this code, paste it here. So the service server is fairly small. Again, these things are covered. Again, to interact with the service server, the service client and the service server should be on the same page, which is the same request structure or the service type. So again, it is the one which we have created. We are importing it here. And here, instead of creating a client, we are creating a service, which is a service server. And the service type is compute rectangle area. What is the service name? The service name is calculate area. And whenever I get a request, the service will call this callback function. So what is this callback function? This is the callback function. So whenever the service is continuously, why we use different packages cannot do in same package? You can do in same package, but it's just that when you are working on a very big robot or which has many components in it, so it is better to have things in different package. That's why we use ROS, to provide modularity. If everything is in the same package, then it is not scalable. For example, if I want to use the same message type in some other robot, then I'll have to, like, I cannot use, I because I have the package for this robot only. But if I create the package separately, then I can just copy the package and place the same package in other workspace, so I can just use it, so it becomes modular. You can have in the same, but this is how generally it is done. So whenever this service server gets a request, it calls this function. Here the request is received and response is sent. So here the request came. Request was in the form of length and width. So I'm just multiplying the length and width, and I am storing it as a response in the area variable. And then I'm simply sending the response, return response. So it will just send the response and the area will get printed. So basically this is the code. It is fairly simple. You just get the request. You, for how do you compute the area? For that, you need to know what is the variable name inside the compute rectangle area. So for that, you have to see interface show, but we already know that it is length and width, so we don't have to do that. And we are sending response as area and then printing it using this function. Again, this is the same. So this was about service server. Now we have set up the turtle messages thing properly. Now we are depending on this package this time, turtle messages package, which we have created. So we have to paste this package here. Besides geometry messages package, in the draw circle.py, we are also depending on this package, turtle messages. So I have pasted it here, and in the setup.py, I'll put a comma here, and I will paste the entry point for service server and service client. How will I do that? Go to setup.py and I'll just copy it from here. Okay. And I will paste it here. So now we have area service server, package name is turtle script, area service server, same for service client. Our node, our package recognizes our node. It is working. Now let's build it and see if things are working or not. So how do we do that? Let's do call on build, and also just see if all the things are saved, because sometimes it happens that files are not saved, so it won't recognize. Colcon build. So our script has been built. Now let's source install setup.bash. If I press enter, sourcing has been done. Now let me run the service client first. So to do that, let's do ROS to run from the turtle script. Let's run, what was the name? Area service, not client, area service server. Let's run the service server first. So our service server is up and running. It is waiting for anyone to send request to it. So it will send a response. So instead of sending okay. So instead of sending request via the client which we have created, let's try sending a request via command line first. So how will we do that? So we will do ROS to service list. If I press enter, you can see that calculate area service is present. Okay. Now, how will I know what is the message type or the service type for this? So ROS to service type calculate area, press enter. Service type is this turtle messages from turtle messages package srv compute rectangle. Yeah. That's what I was thinking. The issue is with sourcing, I guess. Source install setup.py. Hopefully now it should work. Yeah, it is working. So that's the importance of sourcing. Good that this error came. So if we don't source, ROS, the system doesn't know anything it exists. So you have to source it every time. So we sent a request length of 5 and width of 3. And the request is 5 and width is 3. We got an area of 15. Who calculated this? Our service server calculated it. Received request length 5 area 3, sent response this. So this is how service servers work. Now let's see let's try sending request via the client we created. So ROS to run from the turtle, what was the name? Turtle script. Yeah, ROS to run from the turtle script. Let's call the area service client. The moment I run this, the area again will get printed. So here again in the code, you can see in the code we had, one second. In the code here, we had hard coded of the value of 5 and 3. So that got printed. So again, the request sent by our client was 5 and 3. So again, area printed was 15. Now let's manually try to change the request. How do you do that? Why we can change it? Because we have added something known as parameters here. So let's see how to use parameters while running the program using command line at runtime. So ROS to run which package turtle underscore script which node area service client. Now I want to change the values dynamically, so I will do something as ROS args, then I will put the parameter -p is for parameter. My parameter is length length equal to, let's put the length as 10.0, and again I'll put parameter -p, and then I'll put width width equal to, let's put the width as say 4.0. Okay, so now I'm changing the values at runtime dynamically. So the now area should get printed as 40. If I press enter, now you can see received request of 10, width of this area printed 40. So here we have created our own service server, which is calculating the area and sending the response. This is the main thing here. Here we have created our client through which, using parameters, we can change the value at runtime. If we don't do it, the default value will be taken as this, which we just saw. If we do it, the default value will be taken as one which we provided here using command line. We have created a client. Another important thing is we are sending, again, this is how this is done. So it's like, you just have to do it like this. But just for understanding why we are sending asynchronously, we don't want our code to stop once it has sent the request and wait for the response. It just keeps on looping, and whenever the response comes, it gets stored here and we extract the response from here. So it's basically done for a non-blocking program, the program which is non-blocking. It keeps on doing its task, and just whenever response comes, it catches it and displays it or whatever it is supposed to do. So basically this code is only for calculating area, but for example, you are building a complex robot, then one of the part of that node will be calculating area. For example, that node also might want to capture sensor data. So it might happen that if you don't use async, then if you don't send your request asynchronously, then it might happen that after sending the request, the code is stuck there, sensor data is not getting captured. So if you use async, continuously sensor data will get captured, and also once the response comes, it will print the response. So basically, if you use Arduino or some other thing, these are called interrupts. This is basically the concept of interrupt. Okay. So we are good with service clients, service servers, custom message types, custom service types. We look at message types. It's exactly the same. Okay. Till now, if you guys have any doubt, just let me know. Then we will quickly complete our 2 capstone projects because we have less time. The session might extend as discussed yesterday. But till now, if you guys have any doubt, just let me know.
Um, so kindly summarize this, or kindly.
Summarize what?
First, we have to create a messages. Then we
Okay.
have to create a server. Okay.
I
In
will summarize
by
it.
creating a server, actually calculating the area, and to get the area, we can use command line as well, or we create another node which is client node, which get the area from the server, and then show the get the area from the server and show it.
So I'll
May
summarize it quickly. So basically,
I get
what's
it correct or
happening?
not?
Sorry,
I get it corrected or not?
you got it correct, but but it's not that you have to do it the same way every time. It depends on your requirements. So I'll
Oh,
quickly summarize it.
oh,
Basically, what's happening is that we have certain pre-built services which in our case is not working. For example, if I want to calculate, for example, I have this pre-built for okay, for this service spawn service which we looked at yesterday. The service type was turtle sim. From turtle sim package in the srv folder, the service type was spawn, and inside this spawn service, what we had inside this spawn service, we had x, y, theta, and name. This was the request. Then we had response as name. So this spawn service was asking us to send a request of x coordinate of turtle, y coordinate of turtle, and the angle of the turtle at which you want to spawn. And optionally, if you want to send the name of the turtle, send that as well. Once I complete this request, I will send you a response of the turtle which has got spawned. But if I want to create a service that calculates area of rectangle for us, it, for our understanding, not that we are calculating area of rectangle in a robot, we can do anything else, but for our understanding, we cannot use this structure. It's not suitable for us. Since we cannot use this structure, we create our own structure. If we can find a structure from the available ones, it's fine, no worries. But if we cannot find, we create our own package. Say in our case, we created turtle underscore messages package. In that we created an srv folder, and in that we created a area, compute rectangle area, srv. Okay, this was the thing which we created, and in this we gave the structure of request as length and width, and then we got a response of area. We need this, so we created this. Now where will we use it? We will use it by creating a service server. Service server is nothing but a node which performs the action of accepting a request, computing it, sending a response. That's what basically a server does. When we use chat gpt or gemini, those are basically servers. We send a request, as a prompt we get a response. So basically that is what is happening here as well. So we create a server here that is responsible for calculating the area, and whichever client sends a request. So there can be multiple clients. This is client 1, this is client 2, this is client 3. All these clients can send requests to the server and get a response at the same time. So basically this is what is happening. There is a single server, there can be multiple clients. Just that all the clients should interact with the server in this message type, in this service type, or else the server won't understand what is inside this service type. This length, width and area, the interaction, the this thing in which the request is being sent, these things should be same. This. So this was basically what we did now using the code. And we also looked, once we created the server, we interacted it using command line, then we interacted it using the client which we have created, the client node. Both ways it works. We also looked at what are parameters and how to change it. Hope it's clear. Okay, so we are running out of time, but we will see. Okay, so we are good to go with the first Capstone project, which is the Polygon drawer. Now that you guys have understood most of the concepts, this will be a very simple task, fairly simple. So let's begin that. So again, for that, we will open our VS Code. Now here in the turtle script, let me close all these things. So this compute area and all these things was just for explanation. It is not required in the Capstone project as such. Oh, okay, so here we will create a file name named as polygon polygon underscore trawer polygon drawer dot py. We have created this file name. Here we will be writing our node. Let's go here. Let's go back inside the turtle script. Let's go to polygon drawer.py, copy it. Let's see. Let's paste it here. So the program is looking long, but it's very simple. I'll just explain you guys what's happening. Okay, so this is our polygon drawer node ready. Since we are depending on these packages, okay, so this polygon drawer node is depending on the turtle sim package, turtle sim messages pose package, which we looked at yesterday. So we will just copy this package on which it is depending, paste it in the package.xml. So here we have rclpy, geometry messages, turtle messages. Besides that, let's paste turtle sim as well. Okay, so and in the setup.py we will have to add the polygon drawer node. Let's add it on our own only this time. Let's copy this once again, put a comma here, paste it, and here instead of this we will name it as polygon drawer, polygon polygon drawer. And again we will just copy this, paste it here, Control V. Our entry point is ready. Now let's see the concept as to what we are going to do in this node. Let's see the concept first, then it will be simpler to understand the program. Okay, so here what we will be doing is, we know what are parameters now. At runtime we can give any random value and it will accept that. So we will be using parameters to input sides as to what side, how many sides do we want. So if I input 3, the turtle should draw a triangle. If I input sides as 4, the turtle should draw a square. And how can we do that? We can do using this parameter. So I use -p. If you don't want to use -p, you can use -- param as well. You can use -p for shortcut. Okay, so basically here we will be inputting sides, and besides sides we will also be inputting the side length as to what should be the length of each side. So basically this is the project which we'll be doing. So let's see what's the concept behind it basically. For example, let's yeah, let's draw the coordinates first. This is x coordinate, this is y coordinate, this is y dash, this is x dash. Okay, this is the center. Let's assume this as the center. This is 0 comma 0. Okay, so what do we want exactly? We want that this is our turtle. Consider this point object as our turtle. We want that if I enter side number of sides as 3, for simplicity let's enter 4. If I enter number of sides as 4 and I enter side length equal to say 2.5 centimeter, so the turtle should move around and should finally draw a figure like this, which is nothing but a square. So square, the angles are 90 degree. Each angle is 90 degree in a square. So what is the logic we'll be using in the program? I'm just explaining you guys. So what we'll be doing is that since you guys saw that we are subscribing from the pose topic, what is pose topic used for? It continuously tells me where the turtle's x y coordinates are currently, like where is the turtle now in the entire turtle sim frame. So what we will do is initially the turtle will be at center or at rest. Okay. So we will initially capture the current position of the turtle, which is, for example, in our case, let us keep it as 0 comma 0. So initially the turtle is at 0 comma 0 right now. In the code, first we will capture the position of the turtle. Then what we will do, then we will ask the turtle to move forward, continuously move forward like this. Mm, then we will ask the turtle to continuously keep on moving forward. As the turtle keeps on moving forward, at every point, at every time, I'll constantly get the x and y coordinates of the turtle. That when the turtle has moved this much, I'll get to know the position of the turtle. When the turtle has moved this much, again, I'll get to know the position of the turtle, because that uh, subscription is running at a very high speed. So at every point, point by point, I'll keep on knowing the position of the turtle. So what I will do, how will I know that my turtle has drawn a line of 2.5 centimeter? How will I know that? So what I will use, you guys all of you guys must know or might be knowing that to calculate the distance of a line between 2 points, like length of a line, we use this formula: x2 minus x1 whole square plus y2 minus y1 whole square. We use this formula, everyone will be knowing it. Okay, so in our case, x1 is nothing but this, that is the start position of the turtle. The turtle started from here, so this is x1 comma y1. x2 and y2 are changing dynamically every time the loop is running, every time the turtle is moving forward. Yesterday also we saw that when the turtle was moving in circle, x and y values were changing continuously as the turtle was moving forward. So every time we will get a new x2 and y2 value. Again, here we will get a new x2 and y2 value every time as we keep on moving forward. So in the loop, every time we will be using and keep on calculating the distance. Once we get a distance value equal to side length, once we get the distance value, this thing equal to side length, we now know that the turtle had started from here and now the turtle has reached here. So it has completed the side length. Now I want to stop the turtle here, because if it goes beyond this, then square won't be formed. I want to stop the turtle here. How will I stop the turtle? I'll simply put the command linear x velocity as 0. This will simply stop the turtle. And right now we are only publishing linear x velocity, no angular velocity. The turtle is directly moving forwards. So at this point, we will stop the turtle, and then we will ask the turtle to rotate like this. So it makes 90-degree. How will we do that? Again, to find the theta, what we do, how will I know that, for example, user can publish 8 sides? So how will I know what is the angle that I need to rotate? So to find that theta, the angle that you need to rotate, you do 2 pi divided by number of sides. So this will give you the angle which we need to rotate. So in our case, angle will be 2 pi divided by 4, since there are 4 sides. So angle in radians will come as something close to 1.57, which is nothing but 90-degree. So our turtle here will rotate by 90-degree. How will we know that turtle has rotated 90-degree? Again, from the post topic. Post topic, what it used to send us? That's why post topic is very important for a closed loop system. It used to send us x coordinate, y coordinate, and orientation of the turtle theta. So we will now publish, we will not publish linear x velocity, we will only publish angular z velocity, so that the turtle keeps on rotating at its point till it has rotated 90-degree. How will I know that it has rotated 90-degree? Continuously from the feedback I am getting from the post topic. Once it has rotated 90-degree, what I will do? I will do, okay, one side of the square has successfully been completed, and now I will create a variable of sides, and I'll create a variable of side, and I will do side plus 1. That means initially side was 0, side variable was 0. Now side plus 1, that is one side has been created. And I will check that if the side variable is less than equal to the number of sides we entered. For example, the turtle has successfully gone here, gone here, gone here, and came here. Then I don't want to repeat this thing again. So I'll check that, okay, number of sides created is equal to the number of sides I have inputted. Okay, then stop the turtle here itself. Don't let it go forward. So after every side, I will be checking this. Since we have only created one side, we will repeat the step again. Turtle will move forward, move again. So here sides will become 2, 3, come back, sides will become 4. Now when this will check, okay, now sides is equal to number of sides. So now the turtle will stop and we will have a square. Basically, this is what we will be doing. If you look at the program, this might help to get you, like, to understand the program in a simpler way. So now I'll show the program so that things get clear. Again, we all know what are parameters. So initially, by default, I'm giving it a value of 3. That is, it will draw a triangle of side. That is, it will draw a triangle of with 3 sides. Triangle is of 3 sides, and we are giving a side length of 2 centimeter. But I can change these values at runtime as I wish. Okay, parameter is declared. Parameter value has been taken. Publisher object has been created with type twist. To which type it is publishing? It is published to which topic? It is publishing to command velocity topic. From where is it subscribing? It is subscribing from turtle1 post topic. Message type is post, to create a closed loop system. So basically, let me show you once again. So basically what is happening, I am creating a node. This is my node, the one which will be drawing a polygon. It is publishing to the command velocity topic. So the turtle sim node is subscribing from the command velocity topic. I'm writing is that it as turtle sim node, and this is our polygon node. So this polygon node is publishing to command velocity topic. Turtle sim node, which is this one, is subscribing from the command velocity topic, then moving the turtle. Now, how will I know that the velocity at which the velocity I am publishing, the turtle is moving at that speed or not? So I will subscribe this turtle sim node, publishes back to the post topic, and I am subscribing. This polygon node is subscribing back from the post topic to see if things are working as intended or not. So it is a closed loop system. This is how real world robotics also works. You publish motor velocity, then the motors move, then there are something known as encoders. Encoders calculate the real time speed of the motor, then publish back to see if I want my motor to move at 3 radians per second, it is moving at that speed or not. So to correct that speed, we use something known as PID, proportional integral derivative algorithm, to match that speed. So basically, this is the closed loop system we are talking about: publisher, then subscriber. Um, so again, creating a publisher. For command well, we are creating a subscriber. We are creating a timer, that is at what time after every 0.1 second my command velocity data should be published. So after every 0.1 second, this control loop function will be called. So what is this control loop function? This is the control loop function which we will call. We will see it. So again, as I had mentioned, that initially we will we have created this variable current pose. We have initialized it as none, that is it doesn't have any value. Then we have created this variable as start pose. Then initially when the program begins, the turtle is waiting at the point, and we have created the sides drawn variable to check if the number of sides are there or not. We have created that variable and given the value as 0. So now what is the okay, so both node are subscriber and publisher each other but different topic. Yeah, so this is a very good example where this node is acting as a subscriber also and as a publisher also, but with different topics. Same node cannot publish to same topic and subscribe from that. So the topics are different. Okay. We have given a tolerance here. Let me explain you. So as such in Turtle Sim, we don't require to give tolerance. It is very accurate. But when working with real robots, it is very important to give tolerance. Like basically we are using a proportional algorithm here. So for people who are absolute beginners, it might be difficult to understand, but I'll explain this section when we will run the code, so that we will see it visually. Then it will be simpler for me to explain why we are using these two things, why we are using. But right now we are setting the linear speed to linear x, which is to 1.5 meters per second, and we are setting the angular speed, which is angular z, to 2 radians per second. Okay, and here we are publishing the sides and printing the sides and lengths, all those things. So this is the pose callback function. So where is it getting called? Whenever you create a subscriber, whenever the subscriber receives the pose data, this callback function is called. So what is this callback function doing? It is just storing the current pose of the turtle. What does the pose variable contain? It contains x, y, theta, linear velocity, angular velocity. Yesterday we looked at it. How do we know that? ROS to interface show pose type message. You see what's inside it. Okay. So here pose data is getting stored. That is the current pose of the turtle is getting stored. Now let's come to the main logic, the control loop. So when the program has just begun and there is no current position, that is the post topic has not yet published any message, it will just wait here. The moment the post topic publishes its first message that the turtle is at this position, which is in the center, we will move forward. We have created a twist message type, and initially here we saw that initially this variable was waiting, our turtle was waiting here. If our turtle is waiting, then we got the current pose we got from the pose topic. And right now at the beginning, current pose and start pose will definitely be same because starting is there and current position is also there. So this will only happen when it is in the wait loop. The moment this thing is satisfied, then we will not be entering the wait loop again, so that every time start pose doesn't get changed. Start pose should remain same, or else we won't be able to calculate the distance of the line. Only when we have completed the line, then we will change the start pose to the current pose of this one. Then in that case, this will become the next start pose, and then the turtle will start moving upwards to draw the square, and current pose will keep on changing. So here what we do is we initialize start pose as current pose and we change the state as to move forward. Okay. So next time when this control loop is called after 0.05 seconds, here when the timer calls, it sees that, okay, the state is now forward, it's not wait. So now this formula we are using just to create the length of the line, find out the length, root over x2 minus x1 plus y2 minus y1 square. This we are using maths.xqrt. I hope everyone understands it. It's very simple. Now, this is something. Here we are creating the error. Now you will get to know why I had put this here, this thing. Tolerance, distance tolerance and angle tolerance. Let's look at distance tolerance first. What is error? So let's see what is error here first. So what we are doing is self dot side length. We have given a side of 2.5 centimeter now, and this is the distance which is getting calculated. Now what is error? So error is just the difference of these two. So how will you know that? This is how you will know that. Okay, let me draw it here. That my turtle started from here, start position and current position were same. Then my turtle started moving forward. This is 2.5 centimeter, for example. Okay, now this is what I am referring to as side length variable. This is what I'm referring to as side length variable, and the distance is what, okay, the distance is what I'm referring to as after whenever we receive a new post topic, my turtle is slowly moving forward. So every time post topic will keep on changing. So this is the distance. Every time the distance will keep on increasing. This is the distance what I'm referring to. From the start position, every time this will get updated till it reaches this point. When it reaches this point, then the distance will become equal to side length. Then I want my turtle to turn and move above. So the error I am referring to as this thing minus this thing, the distance. So what is left is this. This is what is left. And as my turtle is moving forward, it is constantly getting reduced, as you can see. So I want my turtle, for example, let's take a very intuitive example. When you are driving your car and you drive it at a very high speed, but from the back of the road, from 100 meters only, you see that there is a speed breaker ahead. So you don't immediately stop your car and move it very slowly. You just keep on moving your car very fast, but as the speed breaker approaches, the distance between it decreases. You slowly stop your car, and when the speed breaker reaches, you just almost stop your car and it goes above the speed breaker, then again you accelerate. This is what is happening here. I want to stop my turtle. I want to stop my turtle here at this point. But when I am starting from here, it is not that, why will I drive slow when there is so much distance available? So initially I am driving my turtle very fast. But as this error is getting reduced, that is the speed breaker is arriving, I am gradually decreasing the speed of my turtle. And the moment the speed breaker arises, almost my speed becomes zero. So that in car you like it's very inconvenient, but when you are building real robots, if you keep on driving at the same speed and when the speed breaker appears, it will not stop there, it will overshoot. It was supposed to stop here, but due to inertia it will go ahead. So for that we use proportional controller, so that based on the distance you calculate the speed, and slowly as the error is reducing, that is the speed breaker or the final destination is approaching, you stop your robot, and when the moment of stopping comes, your robot is at a very low speed and it can stop precisely at that position without overshooting due to inertia. This is the main reason behind error what we are using. So this is the P controller, which we call. There are two more controllers to it, I and D for integral and derivative, but we are using only the proportional controller. And while using the proportional controller, you give it a certain value. So I have given it a certain constant value of 1.0. So that's called KP basically. So I have given a constant value, it will just multiply as a factor to it, and as the error reduces, the speed will also reduce. So you have to, while building real robots, you cannot give these values directly. these are done by hit and trial as to how your robots are behaving, how your robot is behaving. Based on that, you have to do manual hit and trial and tune these values. So this is the constant value which you multiply with the error to make it a proportional controller, basically. So what will happen is that linear speed, you guys have understood now, I hope so. So basically we are calculating the error. I just now showed what is error. We are checking if the error is less than self dot tolerance. What is the tolerance we have given? 0.01. That this was the initial error. It is reducing. Now I'm checking that error is less than the tolerance value. Okay, so that means that I have reached my position almost. So now I can turn. So here that's what I'm doing. Error, keep on moving. If the error is less than tolerance value, initially the error was this, but the moment error has become less than the tolerance value, now stop. You have reached your destination. So now we are putting linear x as 0 and stopping the turtle. Then we are publishing the twist message to stop the turtle. And now once we have reached this side, we are doing the start pose at current pose. Now initially our start pose was this and we had to reach here, but now since we have reached here, now we are putting this as our start pose, and now we have to go above to draw a square for that matter. And now since the turtle is like this, I have reached my destination, but I have to turn by the angle depending on the polygon. So now I go to the state turn. I am printing all these things, and till if my error is less than the tolerance, keep on moving the turtle forward. If my error is greater than the tolerance, now whatever error is less than distance tolerance, yeah, so I move my turtle forward. Okay. So basically every time this will come in the else only, because initially my error was this. It is definitely not less than tolerance. So it will come at else and it will keep on moving forward. Once this thing gets true, which is, then it will come here and stop, or else it will keep on moving forward. Okay, now same goes for the turn. I have shown you how to create the target angle, the angle at which I am supposed to turn. 2 into pi maths.py divided by sides. I know the target angle. I normalize the angle. How do I normalize it? Here we have written a normalize function. What it does is, it's just that when you subtract the angle, or yesterday you were seeing that angle as the turtle was moving, the angle was getting negative as well. So the post topic publishes this. Okay. So basically the post topic publishes the angle in a, okay. The post topic publishes the angle in a range of minus pi to pi. We don't want negative angle. So we only want positive angle. So to remove the negative angle, we use the normalize function here, which we have written. If the angle is less than 0, just add 2 pi to it. So it will come on the positive side. Similarly, just subtract. So this is to normalize, just to normalize. And again, just like we were doing to calculate error, here also we are doing the same thing to calculate error. Current pose, which is the current angle, and the start angle. So in our case, the start angle of the turtle was like this, and the no, okay. So initially our current angle was this, and the turtle is slowly moving. So we are getting the error, and the moment my error becomes 90-degree, I want to stop my turtle there. This is what is happening here. Target angle minus target angle is 90-degree, current angle is this, and till when I am moving, if my error is less than angle tolerance, again the angle tolerance was almost 90-degree. So if my error angle is less than angle tolerance, then keep on rotating the turtle. So every time it will come in else only. The moment it will become like this thing will get true. It will come here, it will stop the angular velocity, and it will increase the sides. That is, now we have successfully drawn one side and the turtle has moved. The sides drawn is incremented by 1. And here we are checking, where were we checking? Here we are checking that sides drawn greater than sides. Okay, so we will keep drawing the sides till it becomes equal to or greater than that. Once I find that 4 sides have been drawn, I'll just shut down the entire program. Or else, now I have moved like this. Now again I want to move forward, so here I've given the forward command. Again the same thing will repeat, and my turtle will move forward. And this is the constant value which I am multiplying, the kp, which I was referring to, the constant factor for proportional algorithms. And here I want the minimum speed to get published, whichever is minimum among the two. So this was the basic program for Polygon drawer node. Let's run this and see what happens. So let's quickly build our workspace. Colcon build. Let's run the turtle sim here. ROS to run from the turtle sim no package. I want to run the turtle sim node. Turtle sim. Okay. Turtle sim is running here. Now let me run our node which we wrote just now. ROS to run from the turtle scripts package. I want to run the Polygon drawer node. Now, since I am not giving any parameters to it, so initially the parameter given was 3. So it will draw a triangle. Hopefully it should draw. Let's see. Turtle is moving forward. See, the turtle is initially moving fast, then it is slowing down. Why is this happening? Because of the proportional algorithm which we have written. And it is drawing an equilateral triangle of 60 degree. It's moving fast. See, it's moving fast, but it slowed down as it was reaching the target so that it doesn't overshoot. Now you can see that side 1 completed, side 2 completed, turning, side 3 completed. Now the number of sides has increased, exceeded the required sides. So now it is stopped and Polygon completed. It's showing. Now let's try to make a square. How will we do it? Just ROS args minus p. I will do, what is the parameter name? The parameter name is sides and parameter name is side length. I will do sides. I will only change the sides. I will not change the side lengths in this case. Okay, I'll only change the sides. I'll not change the side lengths in this case. Let's change the side value to 5. So it should draw a pentagon of side length 2 centimeter. I guess we have here. Okay, side length is 2 centimeter, but we are dynamically changing the sides. So instead of 3, it will draw 5 sides. If I press enter, you can see with the same side length, this time the angle calculated is different. So it is moving in a different way. And now here you can see that side 1, 2, 3 got completed as it, yeah, 3 got completed. 4, and our 5th side got completed successfully and our polygon is ready. So this was the final project, Capstone project, not the final one, but let's quickly see what's happening at the backend. Arcutic graph. Let's see. You can clearly see it's a closed loop system. Now you guys can clearly visualize what's happening. This is our Polygon drawer node. This is publishing command velocity to the command velocity topic. From the command velocity topic, turtle sim node is subscribing. Turtle sim node is continuously publishing the current data, the coordinates, to the pose topic. And from the pose topic, we are subscribing to check the current value. And this is an entire closed loop system. This is how robots work on a closed loop system, wherein you give a request, not exactly a request, but you know as to what you are giving is happening or not. This forms a closed loop system. So till now, have you guys understood everything? This was a great achievement for us. From beginners, we have come here. Okay. So, well, in that case, let me ask you guys a question. If I am left with any question. Okay. Just answer this question. The question is, in the draw circle project, how does the Python node make the turtle move? Okay. Definitely it's overwhelming. It's a lot for 2 days. Coding part is a bit difficult, but you explained it in a simple language. Yes. Okay. So the correct answer for this is option B, which is by publishing velocity commands to turtle1 command velocity topic. Most of, I guess everyone has got it right. Okay. Okay, then quickly, we will quickly hope you guys have around 30-40 minutes more. Can you suggest a good book online to learn ROS 2? Books I'm not aware of as such. You can search online. So just type in the chat box that you guys have around 30-40 minutes more. Just type yes. Okay. Okay, so then we will quickly begin. And for practicing Python, there are some very good tutorials available on YouTube. You can check that. Okay. Let's see. So right now what's happening, the problem that we are facing is that every time I want to run this project, I have to run the turtle sim node separately, then I have to run the node which we have written separately. So to avoid this, what we do is we create a launch file. We just write one command and everything runs on its own. So to create the launch file, what we will do is we will again also, for guys, since you guys are beginners, most of you, so it might be very overwhelming, so you can go through the recorded videos once again, then you will get a very good understanding of it. So what I will do is I'll navigate to the src folder where rest of the packages are. I'll press ls. Now I'll create a launch file folder. So we will see what are launch files. So ros2 pkg create, package name is turtle underscore bring up, and build type again. This time this package will be a CMake package. Payment CMake, payment underscore CMake, and we don't have to put any dependencies here right now. If I press enter, our package has been created. I do ls. So here you can see turtle bring up package has been created. Again, this is a C++ package. We will go in the VS Code. Inside our VS Code, we'll go to the bring up package. Here, what we will do, we will navigate to our bring up package. We will press ls, and here we will create a folder named as launch. So mkdirlaunch, launch. This is the launch folder which we are creating. If I press enter, you can see the launch folder got created here. Okay, in this we will be putting all our launch files. Again, we'll go to VS Code. We will go in the turtle bring up. In the launch folder, we will go here. We will create a file. We will name it as polygon dot launch dot py. This is how you write it, polygon dot launch dot py. Okay. So we have created our file. Quickly, we will just go to VS Code, so the GitHub, and in the src, in the bring up, in the launch file, we will copy this code. So basically what is happening, I'll explain you. So here we have created our launch file. Simply, this is the structure that you have to follow. There is nothing to understand here. The only thing is that we are running the node from here only. So initially via command line, we were using turtle sim package. From the turtle sim package, we were running the turtle sim node. But here we have given this thing in the launch file only with the name as turtle sim node. And from the turtle scripts package, we were running the polygon drawer node, and we were passing it certain parameters. So instead of passing the parameters, there is no difference as such. In C++ packages, you write C++ code. In Python package, you write Python code. There is no difference. But it is not that in C++ package you cannot write Python code. You can write, but the file structure differs. And generally, when we create URDF of the robot or when we create the controller of the robot, we prefer CMake over Python. That CMake provides us more flexibility in that sense. Okay, so we were passing the parameters using command line, but now we are passing the parameters directly here only. So the original parameters in the code will get overwritten by this. So let's pass this thing as 4. Let's pass this thing as 4. It will draw a square. Okay, so this is output, is all the logs that are displayed. It will display on screen. So basically these two nodes are running. We have placed this node in our launch file and we are launching this nodes just by one command. Let's see how that can be done. Before that, in the CMake list, you have to change the CMake list and put the launch folder in here. How will you do that? Just go to the CMake list, copy. Everything is same, just that you have put the launch folder which you have created here. Besides launch folder, if you created other folders as well, you put it here. Package.xml, we will put the packages that we are depending on. Just go here. So we are depending on the turtle sim package. Here we are depending on the turtle sim package, turtle script package. So I have added here turtle sim, turtle messages, and turtle script. For the next project, we will be depending on turtle messages as well. So I have added here that as well. Okay, we will just save it. This thing is saved. We will quickly go here. We will quickly go here and we will build. Colcon build. All 3 packages are built now. Now you see the magic. Now let's source install setup.py, enter. Now just with one command, ROS to launch. This time we are using launch file, so we use ROS to launch. ROS to launch. What is the package name? Package name is turtle bring up, where our launch files are present. What is the launch file name? Polygon.launch.py. If I press enter, now you can see our turtle sim node is also getting launched, plus the script which we wrote to move the turtle is also getting launched just with one single command. So it is very handy when you are making big robots or complex robots. There are camera nodes, there are controller nodes, there are various other nodes. So everything you have to launch one by one. So if you place all those nodes in a launch file just with a single command, all the things are launched. So this was the example for launch file. So we have created a square successfully. I'm going fast because we have less time left with us, but you can go through the recordings once again so you'll get a very good understanding. We have completed launch files as well. Now let's move to our final Capstone project. We have successfully completed this project. We now understand very thoroughly that what are message types, what are service types, what is their internal structure, how to see that using command line arguments, and all those things. So now we have successfully completed this. Now let's go to our final project, which is Catch Them All project, wherein we will be building a small game using TurtleSim and ROS2 to show autonomous behavior and how to catch targets and all those things. So let's move into it quickly. Again, we will go to the scripts folder. In the script, we will create a new file. Let's name this file as turtle underscore spawner spawner.py. So yesterday we were calling the service spawn and we were spawning turtle manually using command line. Now we will be spawning the turtle using the program itself. We will be writing and calling the spawn service inside the program. So let's see how can we do that. Okay. So for that, again, we will go to the scripts. We'll go here. We will go to turtle spawner.py. Just copy this. Paste it here. So let's see what's happening exactly here. Before seeing that, let's figure this out also. In the turtle spawner, we are using the RCLPy, turtle sim, turtle messages. Yeah, these are Python functions, so we don't put in dependencies because they are not ROS functions. So we have turtle messages, turtle sim, and RCL. So here we have all three: RCL, geometry, turtle, turtle sim. Okay. We have the required package.xml here, and here we will add our entry point once again. So in our case, the node name is turtle underscore spawner, turtle spawner, and the script is turtle script, and again the node name is turtle underscore spawner spawner. Okay, this thing is ready. We have saved this. Let's save this as well. Now let's see what is happening. So basically, I'll just quickly explain you guys the project, what we are building as the final project, which will be covering all the concepts which we have learned till now. So basically, we are going to build this. This is our turtle sim box, the blue box which we see the window. This is our turtle sim window, and initially there is one turtle spawned at the center. What we will be doing is, in this window we will be spawning turtles randomly at any position: turtle 1, turtle 2, turtle 3, turtle 4, turtle 5, turtle 6. These are, and there will be one central turtle, our turtle 1. Okay, this is the turtle 1. This is turtle 2, turtle 3, turtle 4, 5, 6, 7, 8, 9, and so on. These will get spawned randomly at any position. Our aim is to use our friend turtle 1 and find the nearest turtle. What do you think? Which one is the nearest turtle? For example, let's say T4 is the nearest turtle. So it will just move there and catch this T4. And the moment it catches T4, T4 will get killed. We will remove T4 from the game. Okay. Then after T4, our turtle 1 has come to this position. Now the nearest turtle to it is T9. It will go here and catch T9, and then we will remove T9 from the list as well, from the screen as well. But it can happen that while it has catched T4, but at the same time, because the spawner node will continuously be running, so it has catched T4, but at the same time, say T10 got spawned besides T4. Once T4 got killed, T10 got spawned, but T9 was closer to it. But in real time, after killing T4, next target was T9, but suddenly T10 also got spawned. So in real time, it checked at a very high speed. Okay, T9 was the next target, but now I can find that T10 is closer to me. So instead of killing T9, I'll go and kill T10 first. So it will go and kill T10. T9 will remain there only. Then next target for it should be T5 because it is closer. But after killing T10, for example, T11 got spawned here. So instead of killing T5, it will go and kill T11. So basically, what we are doing is we are using this central turtle. We are using this central turtle, T1 turtle, to catch all the turtles which are nearest to it. So it goes and catches T2, for example, T2, okay, T2 and T3 got spawned and our friend was here. T1 was here. So T1 will catch this one, but next target of T1 will be this one. But while it was going to catch this one on the way, when it was going to catch this one on the way, it reached here and suddenly one turtle got spawned here. So it will cancel this target because this is then not nearest to it. This one is nearest to it, and quickly it will change this direction and catch this one. Once this it has catched this, then it will go here. But on the way, if someone else also comes, then it will go here, and similarly it will move in a zigzag manner and catch the turtles nearest to it. This is the final project which we are creating. Okay, this is a very interesting project. uh, like it clears a lot of concepts. Okay, so let's check our turtle spawner node, which spawns turtles at random positions. So let's go through it. What's happening? We have the RCL node. Yesterday we saw that the spawn service was present inside TurtleSim SRV spawn. So we are calling the spawn service. This is not a message. This is service. This is SRV. We are calling the spawn service. We are calling the spawn service. Then we are calling the kill service. Then we are calling, okay, here we have created our custom message types. From the turtle messages package, we have created a custom message type, which is kill turtle. Just like geometry messages message twist, we have turtle messages message kill turtle. So quickly let's create our new message. How will we create? We have already created the message folder. In that, let's create a kill turtle.message. KILL kill TURTLE turtle.msg, kill turtle.message. At the same time, let's create this one as well, alive turtle.message. Yeah, let's create this alive turtle.msg. When we created services, we named it as SRV. This is message, this is service. SRV message is MSG. Okay, message doesn't have any request response. It simply has the internal structure which it sends. Let's just see what's inside the alive message. Just copy it. In the MSG, go to message, go to alive turtle, just copy this. Inside message, alive turtles, that is the turtles which are still alive, they are not killed yet. So it will have the X and Y position and the count of it. That is it turtle 1 or turtle 2 or turtle 9? So this message will be having this structure. It will carry the count of it and the coordinates of it. So alive turtle, we are using coordinates and the count of it. Kill turtle, we will simply use the name of the turtle which we want to kill. So again, it will be a string format. So we want to kill turtle 10. So string turtle 10, so it will kill that turtle. We will call the kill service, which we had looked at yesterday using command line. Let's save this. Also, since we have created 2 new messages, we have to do this as well. In the CMake, just copy this message we had done for service and go in the CMake list. Here you just paste a live turtle message, kill turtle message. Save, go there, close all this. Polygon drawer, we are done with the messages. Let's come to turtle spawner. First, let's build our workspace to see if things are working. Colcon build. So our build is successful. That is, our system recognizes the message types we created just now. That is kill turtle and alive turtle. We are import. So we want to spawn the turtle at random locations. So for that, we will use this Python function named as random. It generates random numbers between the range you provided. Again, math function provides the tools like pi and all those things. And this is something we'll look at. Okay. So we are creating the class. We initially, the count is 1. That is, the current count of the turtle is 1. That is, only one turtle is spawned right now, which is turtle 1, which gets spawned by default when we open the turtle sim. So initial count is 1. Next count will be 2 because 1 is already present. So instead of giving it 0, we have given it 1. Declare parameter time period. After how much time I want to spawn my turtle. After every 1.5 seconds, we are spawning the turtle. And then we are creating a parameter to, in case we want to change the time period, we can change the time period manually at runtime using CLI. Then we are creating a publisher. We will get to know what is happening exactly when we look at the RQT. But we are creating a publisher, and we are publishing to turtle alive topic. Again, someone was asking yesterday that can we create our own topics or not. This is the example that we can create our own topics. So I am creating my own topic turtle alive to this node, to which this node will publish data. The turtle spawner node will publish data to turtle alive topic, and another node which we will write for catching the turtle, that node will subscribe from the turtle alive topic. Okay. And this node is subscribing to turtle kill topic. The other node which we will be writing will publish to turtle kill topic. This node will subscribe and this node will kill the turtle. So basically this node's function, this is again a good example of modularity and nodes. We can write killing, spawning, and also controlling the turtle in the same node. But for control, we are writing a separate node, and for killing and for spawning, we are writing this node. And these two nodes are communicating via these two topics, alive and kill. So this gives us modularity as to if something is not working, we can check the spawn node. If the control part is not working, we can check the control node. But if you write in the same place, then it's very difficult to debug. Okay, so we are creating a timer here, and after every 1.5 seconds, this timer is getting called and it is spawning new turtles at random positions. So again, we are using this random function to spawn new turtles within these coordinates. So yesterday we saw that the bottom point of the window is 0,0 and the bottom right is 11,0. So it is almost 11. So we don't want to spawn it just at the corner. So we are giving a buffer of 0.5. Let's give a buffer of even more. Let's give a buffer of 1.0 and 10.0. So my turtle will get spawned not exactly at the corner, but 1 centimeter the side of it, and similarly from this side. So the random function generates a random number between range 1 to 10. And it is rounding the generated, since the number is a decimal number and it will have decimal values. So the round function is used to round off the value to 5 decimal places. Okay. And again, since we are generating x and y coordinates, we are also generating random theta, that is random orientation of the turtle. Turtle can be spawned like this, like this, like this, anyway. The range is between 0 to 2 pi. 0 to 360 degree, it can get spawned in anyway. Okay. And here, after the turtle is getting spawned, we are giving the turtle name as turtle1 plus count. So this will become 2. So turtle 2 got spawned, turtle 3, turtle 4, turtle 5, like this. Then I am calling the turtle spawner and sending all this data to this. What is turtle spawner? This is a function which is supposed to spawn the turtle. So to spawn the turtle, yesterday we were using something known as spawn service. So spawn service is nothing but a service server that is responsible for spawning the turtles when a request to it is sent that I want a turtle to get spawned at x, y, and theta with that orientation. So it gets a request, it spawns there and gives back a response to the client that turtle2 or turtle3, whichever turtle has got spawned there. So spawn is a service server pre-built in turtlesim. We saw how to build service servers of our own. So since it is pre-built, we are using only service client. We are acting as client and sending a request to the server that I want to spawn my turtle at this coordinates and this orientation. Then I am waiting for the service server to become available. Once the service server becomes available, I send the spawn request. Once I send the spawn request, in the request I send x, y, theta, and the name of the turtle I want to spawn. Yesterday we saw what was inside the spawn request. You can see once again now as well. If you do ROS to interface show inside the spawn service type, you will see that it has x coordinate, y coordinate, orientation theta, and it has name of the turtle, and response it gives back the name. So again, we are sending the request asynchronously because we don't want the program to get stuck at this point after sending the request and waiting for the response. We want everything to move on. So once the request is sent, we get a response. If we see that response not equal to this, that is, if response we got is not null, that is our turtle has been spawned. If we get a response which is null, then it will show that request failed, because response will be in form of turtle3, turtle4, which is not null definitely. Turtle got spawned, publish callback alive turtle. So where is this program? Publish callback alive turtle. Let's paste it here only. Okay, let's paste it here that it's better. So once my turtle got spawned, what I will do is I will use the alive function. Now see basically what's happening. My node is running. I sent a request to my node that I want to spawn a turtle. I did not give the coordinates. The coordinates were generated randomly. So the random coordinates were sent. Request turtle got spawned at random position. Now if the turtle got spawned, then I am calling this function, and this function is sending the current position of the turtle, that is the x and y position of the turtle, if it got spawned at all. Then it is sending this coordinates to a live turtle topic, to which other controller, to which the other node which you will write, the controller node, will be subscribing, and it will get to know, okay, a turtle has been spawned at this position, let me go there. So it is sending the x and y coordinates over this topic continuously, streaming data continuously. And it is also sending the count as to what is the count of the turtle that is getting spawned. So this was about spawning turtle. This is about killing turtle. When the other node which we will write, the controller node, has gone to that position and killed that turtle, then it will send a coordinate value, that it will send a name that I have killed the turtle 3 through a topic. This topic, through the kill topic, we will receive the name, and we will call the kill function, kill service. Kill service, yesterday we looked at. Kill service, you only have to provide the name of the turtle. Once we get the name, we will call the kill service, and we will wait for the service to become available. Then we will send a request to kill the turtle. The turtle will get killed. This is how everything will flow. This is too much at once, but as we move forward, you'll understand better. Again, this is the same service structure, and here we are seeing that if the response, like the turtle got killed or not, so it will print killed, or else the request got failed. And this is the callback topic. Whenever the kill turtle topic receives something, this function will get called, and it will store the name of the turtle to kill. So here we are calling the turtle killer function, this one, to kill the turtle. Received data, called this function. This function sent request, I want to kill so and so turtle. Sent request, got a response, killed successfully. Game over. Okay. Okay, so this node I have explained. Let's just try running this once. So we had already built our package, I guess. So let's just source it. And here let's just run turtle sim. Okay, cd. Let's do cd. ROS to run from the turtle sim package. I want to run the turtle sim node. I am running this node here. Let's run our program. Node ROS to, have we sourced it? Source install setup.bash. We have sourced it. Let's run our node ROS to run from the turtle underscore script. I want to run the turtle spawner node. If I press enter, you will see that at random position and random orientation, turtles are getting spawned. You will see it is not getting spawned here because we have given a threshold of 1 to 10. So it will get spawned within this box. It will not get spawned at the extreme ends because we have given a threshold. At random positions, the turtle are getting spawned with random orientation. So our turtle spawner is working fine. The moment we write a turtle controller, it will start moving and start killing the turtles. So then the killing thing will also get tested. So for that, we will quickly write the turtle controller node in which this turtle, this is the central turtle, this will move and kill all. Okay. So this is done. Okay. Okay, let's then move ahead and quickly write. Let's then move ahead and quickly write our turtle. Let me just drink some water. Okay, so let's quickly write our turtle controller dot py. This is our turtle controller dot py node. What we will do, we will go in setup.py. Again, we will just copy this, put a comma here, paste it. Here we will change the name to turtle controller. And here we will change the name to turtle controller. Press enter, press Ctrl S. Package.xml is done. Now let's just quickly see our final node, which is the turtle controller node. Okay. So we'll go in the turtle controller node, paste it. Now again, in this case, our node is depending on turtle message, turtle sim, geometry message already present in package.xml, message maths. Okay. Now you can see that that node which we created, turtle spawner, was publishing to alive turtle. Using this message type, it was publishing to turtle alive topic. So here we are subscribing from the turtle alive topic, and that node, the spawner node, was subscribing to the turtle kill topic. So here using this node, we are publishing to the turtle kill topic. So this node is publishing to turtle kill topic. Spawner node is subscribing. Spawner node is publishing to the turtle alive topic. Turtle controller node is subscribing. Again, a closed loop. Okay. Again, these things we have covered. This is the turtle controller node name. Here, these things you'll get to understand as we move forward. So basically, we are using a list of, basically this is a list, so which we are creating, or an array. So we are creating one array, name array, which will have all the names of the turtle which are getting spawned, but it will be unsorted. In what sense it will be unsorted? It will just have turtle 1, turtle 2, turtle 3. But what do we want? We want to catch the nearest turtle. So every time I have to check that this is the nearest turtle or not. So this is unsorted. This is sorted. It will sort in form of the nearest turtle available. This is the current position of turtle 1, our main turtle, which is going to catch all other turtles. So this array will store the current position, basically the data, x, y, theta coordinates, all those things. Again, this is the position to go, which is unsorted. My turtle is here. I want my turtle to go to T3. T3 has a specific position. Where will I get to know the position of T3? It will get published to turtle alive topic. From there, I will subscribe. Again, it is unsorted and I will again sort it. So by sorting it, I'll get to know exactly the target, the next target I'll have to go. So let me just quickly explain the this thing, what all arrays mean. So we have one name array which is unsorted. So unsorted array, this array consists of all the turtles that are getting spawned, but we don't want, for our interest, we only want the name of the nearest turtle to kill. For example, this is the nearest turtle to kill. I want the name of this turtle, so I will sort this array and I will store it in another array which is sorted. Okay, similarly, every time my node, which is the controller node is getting data from the alive topic, is subscribing data from the alive turtle topic, and my spawner node is continuously publishing the newly spawned turtles to this topic with their coordinates. So I am getting to know that, okay, this turtle has this coordinates, this has this coordinates. So it will store the position to go, that these are the positions I have to like these are the positions I have to track and move. But I want to get the target position. What is the first position I have to target? So that again, position array, there is, it has position of all the turtles which I have to cover, but it is unsorted. I want a position array which is sorted, which tells me the next target I have to catch. So again, we are sorting this, and then again we have an array for turtle 1 which stores all the data of the turtle, pose data. It stores x, y, theta, linear velocity, and angular velocity. This array stores this data, so that I should know that where is my turtle at this point, and so that if I know my turtle is at this point, so I can compare all, so I can compare this current coordinate. Let me draw it here. If I know my turtle is at this point and I know that I have to go to this position, this position, this position, this position, but what is the nearest position I have to go? So for that, I need to know this position. Then I will find out the distance between each position using the distance formula which we saw in the Polygon drawer. We will, every iteration we will calculate the distance, whichever is the smallest distance. In our case, this is the smallest distance. We will tell the turtle, okay, go, next target should be this. Then again we will know the current position of the turtle 1 is this. Then again from this position we will calculate the smallest distance to all the points. Then we will know that, okay, the next target should be this. This is how things are working. After every iteration, we are continuously calculating the distance of our turtle 1 with all the turtles available, with using the coordinates, their coordinates, and using the distance formula. Basically, this was the array, name array, sorted array, position to go, and target position to go, that is the next position. Here we are creating a publish twist object to publish twist message to move our turtle 1, create a publisher, and we are creating a kill object, so that once my turtle has reached the target which is it is supposed to kill, then it will send the data, publish the data to the kill topic, from which the spawner node will receive the name, okay, kill turtle 9. It will call the kill request and kill turtle 9. It will spawn a new turtle, say turtle 11. Our controller node will receive the data from the alive turtle topic as to the coordinates of turtle 11. Then again it will iterate and find out the current position and turtle 11 position. It will find out the distance between it and all the available turtles, find out the shortest distance, go there and kill that one. This is how the whole control loop is. And again we are creating a pose of this, subscribing to the pose topic to know the current position of our turtle. And whenever we get a new data, these functions get called. Okay, So this is the function that is getting called whenever a new turtle is getting spawned. So we have to know the x position and the y position of the new turtle and the count, that is the name of the turtle. It is turtle 1, turtle 2, turtle 3, like that. And we are appending it in the list, that is the positions I am supposed to go. So basically I have, for example, I have x1 y1, for let's keep this as x2 y2 position. I have turtle 2 at this, I have turtle 3 at x3 y3, and I have our turtle 1 right now at x1 y1. So positions to go in the list, this is getting appended every time. X2 y2, this is the position to go. X3 y3, this is the position to go. But in the sorted, this is the position to go, but there is another array which is the target to go. So in that I will find out the distance. Okay, distance is smaller or this distance is smaller. I think this distance is smaller. For example, right now these are at the same points, but for example it was somewhere here, then this distance is smaller. Then it, instead of t3 being here in the target array, t3 will come first, and t2 coordinates will go there. So it will basically, it is getting sorted in ascending order based on the distance. Since this distance is less than this distance. So basically that's what we are doing to catch our turtle. So I hope this is the append function which we are using, this one, the name array, and we are appending the name count, and here we are appending the position. That is, we into the list we are adding new coordinates, and at the same time we are removing the coordinates that are getting killed, and here we are adding the names. Then this is the callback function. This tells us the current position of the turtle. Every time the pose data is updated, this function is getting called. We are getting to know the current x and y position of our turtle 1, our main turtle, and theta, and the linear and angular velocities, and we are storing it in current pose turtle 1, which I discussed just now. And if I see that position to go, that is, if there is no turtle, just be there where you are. If I see the moment one turtle is spawned, then position to go will become true. It will have some value, it will not be null. So if it is true, then start this turtle 1 nearest calculation. Quickly calculate the nearest turtle which is to turtle 1, and then move that turtle to the nearest point. These are the two functions. So I have written these functions here. What are we doing? So x1 stores the current pose. So if you guys have basic understanding of Python, this is index 0, this is index 1, and this is basically the array. So here in x1 I am storing this value, index 0 value of the array. This is the array I'm referring to. So this is the array. I'm storing x1 as this and y1 as this, 0 and 1. Okay. So my reference point, which is the turtle's current point, is x1, y1, and coordinates where I have to go. These are the positions, all the positions that are spawned. So I will every time iteratively calculate the reference point, distance from the reference point, and all the positions I have to go. How will I calculate that? Using this function, I'll get coordinate 1 and coordinate 2, and I'll just calculate the distance using the distance formula. And here basically I am sorting. So how am I sorting? I am zipping it. Why is it important? Is because if I sort only the coordinates, the turtle name will not get sorted. So I will reach the target, but I won't be able to kill the turtle. So if I want to sort that, okay, this coordinate is closer to turtle 1, so put this first. At the same time, this coordinate name was turtle 3, so put turtle 3 first. So when my turtle reaches this coordinate, it knows that I have reached this coordinate and this turtle was turtle 3. So I can send turtle 3's name on the topic. Spawner node will receive and kill turtle 3 using the kill service request. Okay. So that's why we use this zip function to zip the coordinates and the name together, so that if one coordinate comes ahead, the name also comes ahead with that. It gets zipped together basically. You can look out more on it on the internet. Okay, so this is the rearrange. We are using the sorted function to sort the array. We are here using the lambda function to calculate the distance iteratively. And here we are using this as the key, and we are continuously calculating the difference between reference point and this array. This is the combined array basically. Let me just explain what's happening here. This is the combined array which we are creating. What will this array look like? Let me just show you quickly what will this array look like. Basically, the combined array will look something like this. The combined array will look something like this. It will have the x2 y2 coordinates, and say it will have this, the coordinate name of this is turtle 2 1, this thing. Then again it will have x3 y3, or for example let's say it will have x4 y4. It is, if it is not sorted or it is sorted, like it is sorted, we know, or we are sorting, we'll see. But it will have again the name zipped together. So if this coordinate is closer, so t4, this coordinate will come here, at the same time t4 will also come here. So this is what zip function is doing. It is zipping the coordinates and the name together, so that we cannot sort the names directly, we can only sort numbers. So if one number comes forward, the name associated to that number also comes forward for killing purpose. So this is what the zip function does. And what it is doing, we are sorting it using the combined array. This combined array is unsorted. We are putting this array here. We are using lambda function to iteratively sort. We are using the calculate distance function, and here coordinate 1 is getting sent as pair 0. What is pair 0? So pair, it is looking in this, and 0, again I just now showed you, 0 is this. This is, this thing is 0 and this thing is 1. So this is basically a list of lists, you can call it. So basically the combined function, you can call it a list of lists, and in that list you have this 0 position and 1 position. Since we have to calculate distance using numbers, so number is stored at 0 position, so we are calling pair 0. Pair is the key there. I'm going quickly because this is just the program part of it, this is not the logic part of it. So this is more inclined towards Python understanding. So yeah, so pair 0 is basically the spawned turtle's position, and reference point we know is turtle 1. We are calculating the distance using this function, and then we are storing all the distances with their associated names in the combined sorted array. So the combined sorted array, and then now here we are unzipping sorted coordinates and sorted names. We are unzipping and then returning it, converting it back to list and returning it. So now the target position is the sorted coordinates. Now my turtle 1 knows that it has to go to this coordinate, and it will go to the target position. Okay, so let's go line by line. Sorted coordinates, sorted names, rearranged based on distance. So let's see what this function is. Where is this function? Okay, so here we have defined this function. I have already explained what is happening here in this function. Basically we are sending the coordinates here, and coordinate names and reference point, we are sending it here. It is accepting it and doing all the things which it is supposed to do. Once I get the response from this function, this thing will return, and since it is returning 2 values, it will get stored here. Once I get the response, I will store the sorted coordinates in the target position. So now out of all the positions, all the available positions where my turtle 1 can go, now in the target position, it has all the positions stored in an ascending manner. That is, T3 is the nearest position, then maybe T7 will be the nearest position, and so on. So basically, this is what is happening here. And in the sorted names, again, the names are in the format of the position based on the distance. Okay, so here we have done this. Now let's move our turtle. We have done all the calculations. We have the raw array, which is unsorted, which consists of all the coordinates. We took that raw array, we put it in the function of calculate distance, in which we calculated the distance between current turtle, turtle1, which is the reference point, and all the available distances. We used the sorted function in Python. We first zipped it so that the distance gets sorted along with the names as well. We used the sorted functions. We sorted it in an ascending manner, that is, which is the distance which is nearest to me. Then we stored that distance in the target position, that is the next target I have to catch, and we stored the names in the sorted names so that if we reach the target, we can kill that target. Now all the calculations have been done, mathematical. Now at the end, I have to move my turtle there. So here, if you are seeing that target position is null, it is not having anything, just keep the turtle there. If it has something, start moving the turtle. So the target position, I want to move to the first position in the array. So definitely the first position will be target position turtle1 of 0, zeroth position, first index. In the zeroth position, first index, it consists of x and y. So I want x. So again 0. People who know programming will understand this. Okay, so this is basically a concept of array. And then if I want to store y position in the first element, I want to store the y position. So I put here 1. Okay. Again, last time we had seen proportional controller. So again, we are giving the turtle a proportional constant of, in the linear x direction, we are giving it as 2, and angular, we are giving it as 6. You can change it using hit and try. Then current position, we are getting the current position of the turtle. So we had stored the current position of the turtle here, what the data which we were getting from the pose callback. And in that, first is the x coordinate, y coordinate, and then the theta 0, 1, 2. Okay. Now, how, what I am doing here, dx dy, I am calculating the target x and the current x, the basically the error between that. So current position of the turtle is say x1 y1, target position, it has to go to x2 y2. We are calculating the difference between them, and we are calculating the distance between them, then uh, using the distance dx and this thing. Then again, so let me okay, let me just explain this, then I'll show this once again. So here we are calculating the target angle. For example, let me show only. Okay. For example, my, for now, let's keep turtle1, turtle2, and turtle3. This is my turtle1. This is my turtle2. This is my turtle3. Spawned at random locations. I found out this distance is less, so let's go here. Now, how will this turtle know that it has to turn here and not there? There is no way to know. Distance is just a magnitude, it doesn't have any direction. How will it know that it has to turn this way and not that way? That this turtle can be here as well, and the distance can be same, so it might go and collide with the wall instead of going here. So how will we know that? To know that, we know from basic trigonometry that if I have this coordinate here, which is 0, 0 or x1 y1, and if I have this coordinate here, which is say x2 y2, and this as x1 y1, I have calculated the distance This is why I did this here. This thing dx, which is target x, x2 minus x1, dy y2 minus y1. I put the distance formula, I calculated the distance. Now I know this distance as d. Okay, that is also I know this value as well, and I know this value as well. Okay, so using basic trigonometry we can do tan theta is equal to this value. Let's keep this value as p perpendicular and this value as b. So tan theta will be equal to p by b. So using that we can find out the theta, the angle the turtle is supposed to turn. Now what will this p be? So this will be x1 and this p will be y1. So basically this will be y1 by x1. Using this we can calculate the angle at which the turtle is supposed to turn to kill this. Okay, now let's just quickly look at the PID part as to why I had kept the k linear value as 2 and 6. For example, if my speed is very high, for example, my turtle is moving at a very high speed. This is the turtle and this is my turtle which I have to catch. And my turtle is moving at a very high speed. And I know the angle that I have to turn by this much angle. I know this. But if my turtle is moving at a very high speed, it might happen that before turning to this angle, because turtle turns slowly, so before turning to this angle, I just offshoot this. Like my target got missed. It can happen. Or so this is being defined by the k angular, which we have put in the proportional controller. It is 6.0. So I have put, it is not a number, fixed number. I have put that after doing many hit and trials, what is working good and all those things. So that's not a number that is fixed. You have to put it accordingly. So it will work for your turtle sim because your and turtle sim and my turtle sim are same, but might differ for robots which we are building, depending on the motors. So what happens is that if I put the k value, the angular value very high, and I want to go from this position to this position, and the angular value is very high, the constant. Right now I'm using kp angular as 6.0. Say for example it is 16.0, it is very high. So this turtle, instead of moving and going here like this, what it will do is it will start wobbling and it will start going at here like this, because it turned at a very high rate. So it just got offshooted. So offshoot happened, then it recognized, oh, I like the angle that I was supposed to go is not correct. Now I have to turn back. So this pattern will be formed if your k value is very high, kp value for angular data. If it's very low, then if you want to go here and your speed is very high, you will not go here, you will miss it. You'll just have to put it accurate enough so that your turtle goes and takes a turn and just hits the target like this. This is the importance of proportional controllers.
We can also do that. First we can only turn the turtle and then move straight towards the target. This can also be achieved.
You can do that, definitely you can do that, but it will not be that efficient and it will look very like scrappy, kind of like, will not be that better. But definitely you can do that. That is one way of doing it, definitely. But if you understand this, this is a more better way and interesting way, but that can be done definitely. Okay, so that's why we have put this as this and this as 2.0. That is, if the distance is very much, then my turtle will move at a high speed, and as the distance approaches, it will start reducing its speed. Okay, so using the tan thing, I am calculating the angle, target angle. Then I'm checking that target angle minus current theta, just like we did in the polygon drawer. We are checking that the angle which I'm supposed to be at, am I at that angle? If I am at that angle, well and good, move forward. If I am not, just keep on correcting it. So that's, and this is the normalization thing which we were doing last time. just to keep the angle positive. And here I am publishing the angular velocity by multiplying 6 into angular error. What is angular error? Where are we calculating? Yeah, angular error is nothing but the current angle minus target angle minus current angle. So this is the angular error, and this is the linear velocity at which we want to move. So basically, as we move forward, the distance is decreasing, that is the error is decreasing. So as we are moving, reaching our target, our velocity will also keep on decreasing because this value is decreasing. Similarly, this value is continuously decreasing as we are reaching the right angle. Okay, so now every calculation is done. We simply have to publish linear x, linear velocity, angular velocity, and publish the data. And again, if the distance is less than 0.5, that is the threshold distance which we can keep. If it is less than 0.5, that is almost I have reached the target position. So just stop the turtle there and wait for next turtle to spawn and then go and kill it. And then publish this to stop the turtle. Target reached, it will print. And then what it will do is it will remove the turtle which got killed just now. Which turtle will get killed? One which is present in the first position in the target position array. We will use this to just remove that this turtle got killed. Let's get to the next target. And whatever we have removed, so this is the name we have removed, we will store it in name to remove. And then this is the name to remove, the one present in this, and we will send it to the topic kill turtle. Kill turtle will receive the name to remove and call the service kill, send the name, kill the turtle, and that turtle will get removed. And here we are calling the kill turtle function. And the kill turtle, in the kill turtle, we are using the kill request and we are sending the name to remove and then publishing it over the topic kill, turtle kill, whatever the name was. So basically we are doing this here. Again, this is the same. So this is the final code. Let's try to run it once. Before running it, let's create a launch file for this, because to achieve this project, we have to run 3 nodes. One is the turtle sim node, one is the spawner node, and another is the controller node. So instead of running 3 nodes, let's run only one command. So let's launch, go there, and let's name this launch file as catch them all .py. If I press enter, this thing is there. Let's copy the launch file from here. Launch file is in bring up package, launch, catch them all, copy it. So here we are running 3 nodes, turtle sim node, turtle controller node we just wrote, spawner node that had a parameter of spawning time period. So initially that had 1.5, but here we are giving at 1. So that will get overridden. So every 1 second new turtle will get spawned, then we are launching this. Okay. So we have a launch file ready as well. We have set up the package.xml, setup.py, everything. Let's run. So we don't need this node, this terminal now, because only one terminal is required. So we'll go inside the turtle sim workspace. We will do colcon build. We will do source install setup.bash, press enter, run the script, run the launch file now. So ROS to run from the bring up package turtle underscore. Okay, so yeah, from the bring up package, I want to run. Okay, so it will not be run since it's a launch file. So we have to use this command ROS to launch from the turtle underscore bring up package. I want to launch this launch file. Why is it not getting launched? turtle bring up, launch, catch them all. Am I doing everything correctly? ROS to launch, turtle bring up. If I do Polygon, it's working. Let me see once again. We have okay. So why it was not happening was that I did not name it as launch.py. Rather, I named it only as a Python file. It's not a Python file, it's a launch file. So you have to name it correctly. So catch them all .launch.py. Now it should work. Now if I build it once again, cd turtle sim workspace, I do colcon build, and I do source, I do ROS to launch from the turtle underscore bring up pack. From the turtle underscore bring up package, let's launch the catch them all .launch.py. Let's launch it. If I press enter, you can see what's happening. Random turtles are getting spawned at different locations, and our turtle is catching them. See, you can see one turtle was spawned earlier, but it went and caught the turtle which was nearest to it. So let's try and keep like spawn the turtle after every 0.5 seconds instead of spawning it after every 1 second. Again, let's build the workspace, source it, launch the project. Now after every 0.5 second, new turtles are getting spawned. So it is not that it is catching the turtles which were spawned in order. It is catching the turtles in the way they are closest to the main turtle. So this is the final project. Finally, we have completed. Okay, so let's do one thing. Let's see what's happening at the backend once as well. Since we have come a long way, let's see what's happening at the backend. If I do ROS to node list, 3 nodes should appear. You can see a controller node, spawner node, and turtle sim. This node is appearing. Now let's quickly see RQT graph, what's happening at the backend. Get a complete understanding of it. So this is what, as our robot grows complex and complex, the RQT graph also starts growing complex. So see, this is the turtle one, and this is the okay. Let me zoom in a bit. Now it's better. So 3 nodes are there. Turtle one, turtle sim node is there, turtle controller node is there, turtle spawner node is there, and these are topics. So what's happening? Let's see. So what we are doing is using the turtle spawner node, we are spawning turtles and we are publishing the coordinates of the spawned turtles over the turtle alive topic. From the turtle alive topic, turtle controller node is receiving and it is sorting, and it is getting to know that at this positions my turtles are there. Then it is computing the distance from each turtle, the turtle one. From the turtle one, we are computing the distance of each turtle, finding the shortest distance, moving there, killing the turtle, and at the same time, it is subscribing from the pose topic to know where the current position of turtle one is, and then it is publishing command velocity to this command velocity topic to move the turtle. The command velocity topic is publishing back, as this is the entire same structure in the Polygon drawer, but here the closed loop is this: controller node, spawner node, coordinates getting published, receiving the coordinates, targeting it, moving there, killing the turtle, then publishing the name of the turtle to be killed over the turtle kill topic, spawner node receiving that name, calling the kill function, killing it. This was the entire project you can see here. Okay, so we have completed this project. Now I would like you guys to do these two projects on your own, and I have a challenge project for you guys, wherein what you have to do is, so there is something known as this ROS to run teleop twist keyboard. Using this command, you can move your turtle using your keyboard keys. Whatever will display on the screen, you can move your turtle using your keyboard keys. So I want you guys to create a project wherein you move the turtle 1 using your keyboard keys, and there is a turtle 2 which keeps on following it wherever it is moving. It doesn't kill it. There are not many turtles, there are only 2 turtles, but one is moving with your keyboard keys using this command, ROS to run teleop twist keyboard, using the keyboard arrow keys or the other key. We are almost, we have almost reached the end. So I want you guys to do this, and with this we have completed our 2-day boot camp on ROS 2. Now you guys understand what are nodes, what are topics, what are messages, services, parameters, custom Python nodes, message types, CLI, RQT graphs, and everything. You guys now know everything. And before we will wrap up, let's just turn on our cameras. Also, before that, this was one of our boot camps. Next boot camp series, we will be covering, now that we know the basics of ROS 2, we know what are the core concepts. Now we can move to the real part of building the robots. So in the next boot camps, we will be covering how to design your robot using 3D CAD, create the URDF, export to ROS to gazebo, controllers, navigation stack, move it, and everything will be covered. So just stay tuned, and uh, yeah. So this was the end. Before that, I would like to know, how was the session? Was it helpful? Did it add anything to your knowledge? Just unmute now that you guys all are on camera. Just unmute and reply.
Yes, actually, it's very helpful. Getting knowledge as a beginner on the ROS, it's good actually. Like I have been searching for many YouTube tutorials or some Udemy courses, but I didn't get this much of clear knowledge and detailed knowledge, like a basic introduction about ROS and about the turtle sim and everything. Like I got a confidence that I can move on to the next step actually. So thanks
Definitely.
for that.
Definitely. Welcome. Anyone else would like to say anything? It was difficult to understand robotics part as I am from mechanical background. No worries. We will ensure that you understand in the next sessions. Okay, so we will just click a quick screenshot of it. Just everyone smile. Okay. So we have taken a quick screenshot, and now I have taken a lot of time, and now the session is officially over. If you guys have any Q&A, you can ask, or we will end the session. Or before ending, let me ask you guys one more question which I have in my poll. Let's see. Okay, let just answer this last question and then we can leave. You suggest some good programming YT channels. Yes, the correct answer for this is option C, the last one. And for programming channels, I don't know much. For robotics, I can suggest there are some good channels like Robotics Backend or Articulated Robotics or the Construct. But for programming, Python programming, you can look for Paul McWhorter's channel. I learned from there, at least. Besides that, I'm not aware of any. Okay, so it was really great having you guys. It was a great time for me as well. Hope that it was same for you guys as well. So now Geeks for Geeks never went there, so don't know much about it. But so then we will end the session, and just keep an eye on the WhatsApp group. If you are not there, just join the group, and on your emails for the next updates on the workshops. So see you guys in the next workshop which we will be conducting. It was great having you guys. Thanks. Recorded video will definitely be provided in by Monday or by Tuesday max. It will be provided with the materials which I mentioned, the installation steps and the GitHub template and all those things. Everything will be provided, and the certificate. So I'll email you guys a feedback form. Just fill that form with your full name and all those things, and the certificate will be emailed you with will be sent to you guys by Monday or Tuesday max. And I would request you guys to post that certificate on LinkedIn and tag me as well, or the projects you make, tag me as well. So that would be really great. I know how ROS works. Thanks. Finally. Great. Welcome. Okay, then. Fine. Bye.